Hi grade 12, welcome to my channel. Let us discuss this question paper from KZN. And of course, this is in preparation for the finals or any other exam you may see after this video. I must extend my gratitude to a gentleman from KZN who sent me this question paper and many others. In fact, I would not have been able to do this video had he not sent me this question paper on time. So thank you, folks, and keep supporting as you are doing. It's already a very good thing because this collaboration is starting to prove ever more successful. And this is all for one goal: to assist you guys to have enough ability to handle any mathematical exam in metric, and hopefully for you guys to do well enough to gain a spot at an institution of your choice for a degree that makes your heart tick. Alright, so this is the trial paper from KZN for 150 marks. Of course, instructions, guys. There's beds. And of course, guys, very important how we round off and stuff. So 2 decimal places only this time. And of course, we know that instructions, sometimes it gets moved around and all, but this is very important, okay? And of course, read all the other instructions, guys, because, you know, sometimes not doing so is going to lead to some unnecessary losses. Okay, let's start with question 1. Now, question 1 is bivariate data here, which is a purely grade 12 topic. Told you that a road traffic inspectorate is doing research on the legibility distance. Okay, what is that? We're told that this is the maximum distance at which the driver of a vehicle can read a road sign. Okay, never knew that. It's a maximum distance at which a driver of a vehicle can read a road sign. So it's called a legibility distance. Now, for their research, they tested 12, so very important to handle totals. They handled 12 drivers of different ages to determine their legibility distances. They hope to improve road safety by examining the relationship between age, measured in years, and legibility distance measured in meters. Okay, at least you were told this is the X and the Y variable. The table below lists the data obtained in this way. Okay, so we can see there that 19, quite a large distance, and then it seems to decrease over time. So this is suggesting that there is a negative relationship between these two. In fact, negative correlation. It's going to be linear, of course, because this is the least squares regression line. Now we just need to think about the strength where we can find out from the correlation coefficient and stuff. Okay, so let's see. 1.1 says we need to determine the least squares regression line. So this is cool. So let's go for it, put it on the table. So we know, guys, what we're gonna do here. We go to mode, we choose the stat, and from the stat option we choose A plus BX, and then it gives us our 2-column table. We fill it in and then we hit our AC button to store. Okay, so let's go for it. Mode, stat, A plus BX, and then we start. 19, 24, be meticulous, 28, 29, 32, 35, 49, 55, 63, 74, 79, 82. So I've got exactly 12 entries, but make sure, guys, the digits are inserted correctly. It happens that mistakes can occur. So the first one for Y is 155, 149, 155 again, 131, 128, 137, 136, 128, 110, 109, 94, 90. Okay, I've got exactly 12 entries, and then I press AC. Now we need A, we need B, and then we define the equation y cap or y bar, whatever that is, but it's not actually bar, it's an accent or a cap, if you will. Right, so what we do next, the actions that follow, we go to shift, and then we press button 1, and then from here we choose a regression. This gives us A, B, R. We can get the standard deviation. In fact, before that we can get the mean in terms of X, and then the mean in terms of Y. Standard deviation in terms of X, standard deviation in terms of Y. So these are the things we can get there. So let's go shift, number 1, regression A. So A is 169, comma, to 2 decimal places, it's going to be basically 60. Right, to 2 decimal places. So B, we repeat the process, shift 1, regression B. This gives us a minus 0,90 to 2 decimal places. Therefore, our Y accent is going to be 169,60, minus 0,90x. That's the least squares regression line. Okay, very easy, guys. So we can see that this suggests that this distance decreases with age, but actually in reality, you know, most old people, the book starts from in front of the face and then it goes to arm's length. They can see better at a farther distance than closer, because the lens becomes pulled by the suspensory ligaments and becomes more flat. So they are far, what you call, they are far-sighted. They see far because the lens is flat and stiff, so it does not become convex and flexible. So they can't see, they can see you from a distance and say, there he is coming. But when you are close by, they'll be asking you, who are you? So yeah, that's actually not quite true. The table is lying, but hey, we take what we are given and we get the marks, guys. So next one, 1.2 says we need to write down the correlation coefficient, that's R. So we know that R is, go back, shift 1, regression, then we choose R. This is minus 0,93 to 2 decimal places. Again, easy one mark. So 1.3 says, by referring to your answer in question 1.2, we need to comment on the relationship between the age and legibility distance. We can say here there is a strong negative linear correlation between age and legibility distance. Okay, of course, try to answer in full always. Okay, try to answer in full. So the most important is this statement, there's nothing more, right? So we get our nice 1 mark, but we try to be as complete as possible. We are not to talk telegraphically. All right, predict the legibility distance for a 33-year-old. Give the answer correct to the nearest meter. Okay, so we know that our y accent is 169,60 minus 0,90. Instead of this one, we write 33 instead of x. Okay. So we know that this implies that our y accent will be. So we can use our stuff here and say we've got 169,60 minus 0,90 times 33. So we get here 139,9. Therefore we can say here the legibility distance is going to be, we round up, so it's going to be 140 meters, right? We were told this is in meters. By the way, I forgot. Okay, R is a ratio, so yeah, there's not something, I mean, there's not a lot for us to say. We can leave it at that. So exactly, guys, what have we done here? Substitutions and rounding off to the nearest meter. We get our 2 marks. Nice and easy. 1.5 says, calculate the estimated decrease. Okay, the word estimated, we normally estimate a mean or a standard deviation, right? This can go for both x and y, since we've got bivariate data. Now when you say a decrease in legibility distance, now any decrease in a function, because we've got a least squares regression line, this may be related to the gradient. Okay. Per age increase. See, now the age is increasing of 15 years. So obviously, guys, the two things that tend to be affected here, because if we just increase the age only, the gradient is not going to do anything on our equation. It goes together with the equation. It's just going to end up, if we're shifting the x, everything shifts, but the gradient tends to be constant, you see. And when we change x, even the standard deviation sometimes tends to be constant. It's not affected by an equal change in the x values. So I would imagine we're looking at something related to the mean. Okay, I'm not too sure though, but this is what happens. Okay, so we're looking for an estimated decrease in the legibility distance. And of course, we know that the legibility distance is defined by our least squares regression line, right? Per age increase of 15 years for people over 18, okay, meaning above the age of 18. Give the answer correct to the nearest meter. Okay, so what it seems like, we know that the mean in terms of x is going to increase, because if each data point on the x increases by 15 years, the mean that we had is going to increase by 15. Then to estimate the legibility, remember the mean of the x values is going to correspond to the mean of the y values. Now if we increase the mean of the x values, we want to know what would be the mean. It looks like this question is saying what is y bar when we change the x values. Not, y bar, the mean on the y values. So that's what I'm thinking. But again, questions like these, guys, are higher grade questions. There's always a highish, gradish question in there, so please be ready to handle it whenever you can see. But what we know, guys, is that we just need the mean here. We can just say the mean of the x values is going to be the mean in the original sense plus the 15. Okay, so now we need to find out what was the mean. Go shift, then we press stats, but this time we go shift one button, and then here we're going to choose the variance, because that's what gives us the mean. Instead, we're not going to choose regression. And now we're looking for the mean in terms of x, so we're just going to choose x bar. All right, so this tells us that this is 47, maybe we can just do to 2 decimal places in essence. So this is going to be 42, right? But again, this is an intermediate answer, so sometimes you may want to go a bit more. It doesn't matter. But I think this should be fine. But you know, for accuracy purposes, only the final answer we can do that. So let's say this is 417. Sorry, this is 417. This is years, right? But now we don't really care. So the mean is going to increase. But why do we know it does? We know that the mean is equal to the sum of the x values divided by their number. But now the sum has increased while the number stays the same. And we know that the mean is directly proportional to the sum of the x values. So as the x values increase, the mean should also increase by the same measure. Okay, that's fine. We can say then, we know that the y-accent is going to be 169,60 minus 0,90, and then we want to put this one, because remember the equation of the least squares, by definition, once we say the line of best fit or the least squares regression line, we say it's the line that passes through the mean of a univariate data, right? It passes through the mean. So this is why we can use the equation to find the mean when the x changes. So we can say here, guys, therefore the y bar is going to be, now we go back to our equation, we say 169,60 minus 0,90 into 47,417, and then we get our answer there of 126,925. So we can say therefore, remember the question was legibility decrease, so therefore the legibility distance, therefore the decrease in legibility distance is going to be equal to, when we round up, this is basically 127 meters, because we were told to round up to the nearest. So the nearest here is 127. Okay, so this is what I think, guys, but I wouldn't be so sure if I'm answering the right thing. But again, I mean, it goes with just saying sometimes in these question papers you may lose, you may win, it doesn't matter. But I think this is important and this is important. Okay, the actual substitution, we got a mark for it above, but I think this is perhaps how it's done. But again, guys, when the formal marking guidelines come up, you will be able to review this and see if everything is right. But remember, in the exam, you see this for the first time and you have to deal with it. So at some point, don't get too attached to memos, but be more attached to methods of how to get things solved and to see how to gather the clues within the question. Okay? Because there are always clues. As you can see, estimated, we normally talk of estimated mean and standard deviation. And when we look at the legibility distance, it's defined by the least squares regression line. And we are changing the x values. So technically the mean of the x values will change, and therefore the decrease in general. Because if we look, the most important thing I forgot to highlight is that everybody here is over the age of 18. That's why we know the mean is going to increase for everybody, because the youngest person is 19 and the oldest is 82. So yep, so that's how it works. Okay, guys, so let's get to the next question without wasting time. Question 2 reads, a farmer germinated 200 seeds, so I get attached to totals, guys, of a rare and valuable tree species, and planted the seedlings in pots. The pots were placed in a greenhouse where they would grow faster than outside. Okay, should know this from photoelectric effect, okay, as to why. And also understanding plants that green attracts the UV light. Is it UV light, Kanin? Attractor, which part of the spectrum? I forgot, guys, but there's a part of the spectrum that the green attracts, and therefore this helps to catalyze basically the reactions that make up the food in this plant, so that we can eat them, or even at least to help them grow. So after 1 year, the lengths, see, after 1 year, the heights of the trees, okay, we're dealing with heights of the trees in the pots were measured, okay, and an ogive was drawn, okay. The shortest tree was 41 centimeters high, and the tallest tree was essentially 88 centimeters. Right, okay. So what are we going to do now? I'm going to look and say, there's the ogive given to us. So obviously we know that this talks about the totals, the last plot there. And if we look at the classes, it's basically the spaces between these. We can see that one was just to anchor it, but the lower class has those trees of a height up to, but not exactly 50. And then the second class is going to be from 50 to 60. And then the third class is going to be from 60 to 70. So it's going in tens. Then the other one to 80, and then the other one. But remember, we only plot the upper limits of each class. So it's not exactly those values per se, but it can include those in essence. All right. Okay, all right. Now, yeah, that's what we can do here. All right, so at least we understand, guys. And then of course the steepest part of the ogive, which seems to be here. If one was to be asked what would be the modal class, that would be the steepest component. So that would be the modal class, meaning from 70 to 80. So please, guys, make sure that you get these things right. Don't flinch. Get the marks. All right, let's see. Draw a box and whisker diagram of the heights of the trees after 1 year using the number line provided. Unfortunately, it doesn't look like we have it. Let's just check. This one doesn't have it, so I don't know, guys. Please, man, give us everything, man. We want everything, so that we can show students how to get these things done, because it's just small little things that trip students here. Anyway, we're gonna make our own, guys. We don't have a problem. We can do it. So 2.1, we can just create our own lovely scale. We can see these heights range from say 40 up until 90. So I mean, we can go straight from say 0, we can go in tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, maybe we say 100. So this is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So of course we can create our own, but make sure you use a scale drawing, because, but again, in this case, one should answer according to the instruction in the answer book, but I don't have it now. So the one thing I want, guys, is to just create some nice vertical line there and check that it is indeed 90 degrees. Okay. Hey, it doesn't look so much 90 degrees, but I can trust it. Okay, yeah, it looks a bit okay-ish. I can trust it. Then we need to draw the box and whisk. Of course, now, guys, what we need Q1. And Q1 here, once we have an ogive, it's just going to be a quarter. Q1 is a quarter of n, okay? Meaning the total. The total is the last one. That's the total number of things in here. And then when we want Q2, this is basically 2 quarters of n, okay? It's different than when you're using sort of like univariate data, so don't get caught. So the Q3 is going to be 3 quarters of n. And then of course, the last one, the maximum is going to be, 100%. Whereas the minimum is, what is it? Is it 0%? Yeah, something like that. So technically this is what we need, guys. So now we want Q1. So this is going to be just a quarter of 200. Okay, let's go back to computing mode, because every button now starts to malfunction. So we've got a quarter of 200. So that's going to be 50, right? Right. So we know that, of course, it's going to be half of the lower half. So we take it to the ogive. It goes over there. No, I've overshot. This one stops there. And then it comes up like that. So this gives us our Q1. So this value over here, we now need to know how to this rate from 40 to 45. There's how many? 1, 2, 3, 4, 5 ticks. So this means it goes in 1. So this is 55, 56, 57, 58. So we can say our Q1 is 58 centimeters, sorry. Right, so is it correct to say 58? Of course, the upper limit of this class was 60, but we can say safely this is part of those numbers. So in essence, we can trust Q1 to be that. Okay? Although we cannot trust the limits, because the limits may be lying, because remember they are the bounds, so we may not get a true value. So this is why I suppose the examiners decided to tell us the boundaries, because these ones are not easy to guess from an ogive, but anything in between, when it falls on it, it is that. It is exactly that. Okay, so now again we want Q2. So this is 2 quarters, which is essentially a half of 200, which is just going to be exactly 100. Okay? So there is 100, we take it to the ogive. This one, and they totally actually, but yeah, I think this 100 goes all the way to the dot. The dot was meant for the 100, and then we drop it down nicely. So that value 70 is going to be Q2. Okay, so again, it's right on the boundary, but again, look, it is what we get. So this is fine. We can go for it. We can go for it like that. And then last one, we need Q3. Q3 is 3 quarters. So basically 3 quarters of the total, which is 200. It's going to give us 150. So we know that this is the half of the upper half. Take it to the ogive. It looks to be going right there. Okay, of course, guys, the one annoying part about this, so this is 76. Q3 is 76 centimeters, okay? And of course, we're told what the maximum and minimum is. So once we have all of these, then we just put it nicely on our lovely thing. So we can move this and say minimum was 41. So if we say 41 is right around here. So I'm just using this line to get my points right. So I'm going to put 41 here. And then I move my thing 270. So this is good. It's over there. So there is 70. And then, oh, we forgot 58. We forgot 58. It's just before 60 somewhat. So we need, that's our Q1. Then we move to Q3. We got what? 76. 75 is right around here. 76 is just off. And then the maximum goes to 88. 88 is just before 90 somewhat. Okay, so that's what we have, guys. So now what we need to do is to get rid of the line and start doing the things, because remember this one goes inside the box. Okay, it didn't come out nicely. Okay, that's better. And then of course it must be straight. Yeah, so that's the one. And then of course, guys, these ones were not supposed to be there. They were a means to an end. Okay, great. So we connect our whiskers to our box, and then of course we can shade them. Right, so this is our box and whisker diagram, guys. It's done. Okay, it's done. But of course I do believe it would be prudent to show this unit and then to show that unit and this unit as well as that unit. Okay, I think it's a must. So this is 41. Of course this is in centimeters, right? The scale. In fact, I don't know what I'm doing. So we know that the scale is in centimeters. Okay, so this is 41. This is 58. This is 76. Aye, but this 76 looks horrible. Okay, it's fine. 75, okay, 76, it's not bad. We can say this is 88, it's fine. Sometimes the scale defeats us, but I would rather we indicate those, guys. And then, yeah, that should be it. That should be it. So we get our marks here. We're getting 3 marks, so we should get our 3 marks. We've done everything. So let's go to 2.2. Says describe the skewness of the data. Of course, normally we can see that from Q2 to the minimum, you see there's much more space than from Q2 to the maximum. So this means there's more data points to the left. Or we can look at this box. You see that area is disproportionately larger than that area. So this tells us that if we were to get the mean of these data points, the mean would lie to the left of Q2. So this is a negative skew. So it is negatively skewed, or we can say to the left. And sometimes if one says give a reason, you can say the mean lies to the left of our median, which is Q2. Okay, this is the justification. The mean lies to the left of median, which is Q2. This is usually an explanation if it is needed, because once you see this kind of a situation, it means the mean is going to be where the most data points are. It's never going to be to where the least are. Okay, that's the logic behind it. So 3.3 says the trees can be sold as soon as they have reached a height of 75 centimeters, meaning they will belong from roughly Q3 up until maximum. Okay, that's when we get to sell them. Okay, so this says, will the farmer be able to sell more trees? Okay, when will he sell more? Basically, that's the question, I suppose. More trees in the short term. Okay, now what short is short? But anyway, we're told this is 1 year. Okay, I think 1 year is a short term at least, because this can go for many years. So maybe 1 year, because that's what we know. And knowing that this is the growth of trees, they can really go far. Okay, will he sell more trees in the short term if the data set is skewed to the left or to the right? Obviously, the data is skewed to the left, and that means most of the trees in 1 year are less than 76 in height. So that means he's not going to be able to sell these in the first year. But the ones that are already above, he can sell. But can you see there's less than the ones that he would not sell? But if we were to skew the data to the right, meaning there will be more data points this side than that, then definitely he would sell more trees in the 1 year. So we can say it is when the data is skewed to the right. Okay, and just say skewed. Because when more trees fall into that category of from Q2 up until to say maximum, then in essence there would be more trees to sell in just 1 year. So when skewed to the right, perhaps that's the correct one to say, because this was a question of when will it happen. When the data is skewed to the right, let's say, let's answer fully. When the data is skewed to the right. You see, you need to answer properly, guys. Yes, it's 1 mark. 1 mark for that as well. Right, so let's do 2.4. 2.4 says the farmer selected 14 trees to undergo special experimental treatment to make them grow faster. See, genetic modification here is in place, and this is what is killing vegetation, because these things, guys, are not helping. They're bringing in very bad species of trees that are not useful for even the ecosystem in which they are. And as a result, we have a lot of diseases. Birds are dying, we are dying, insects are not doing their jobs. So you see, we're just creating an imbalance. We need to stop being impatient. There's no point in rushing things. Anyway, people are greedy. The heights of these trees in centimeters are as follows. Again, we can see this is in ascending order. So this is now switching to univariate data, right? Now we said calculate the standard deviation. That's easy, it's calculator work. But now what we do, we go to mode, and then we go to stat, we go to variance. Sorry, one variable statistics, one variable. So this is like this, statistics, and then we go to, we get our table, a univariate column table, stats, and then we choose one variable, and we fill in those things. So 46, make sure you do it well, guys. 47, 51, 53, 53, 56, 62, 68, 70, 71, 74, 77, 81, 86. So I've got exactly 14 entries. So from here you go to AC button to store the data. Now the actions to bring the answers is going to be shift, choose button 1. This time we choose the variance. So shift, start the variance. Then from the variance we can choose our standard deviation. Now this is one variable, so we can go for it. So we choose the standard deviation. So we know that our standard deviation here on the x variable is going to be 12. Now to 2 decimal places is 63 centimeters. Remember, this one was in centimeters, we were told. Okay, right, so we need to make sure we write everything down, so the value and the unit proper. Okay, so this is not answering the question. Even dangerous things, 2.4.1. okay, so 2.4.2 says how many trees have heights outside one standard deviation from the mean. Okay, now we need to show our workings. Okay, this one is easy too. We know that one standard deviation outside mean is such that we take the mean, we subtract the standard deviation, and we take the mean and add the standard deviation. So this implies that the bracket we're working with is the mean. Oh, we didn't check it, so let's find it. Go shift 1, and then we go for the variance, and then we choose the mean. So the mean here comes up as 63, to 2 decimal places is 93, minus the standard deviation. We got 12,63. Then here we're going to have 63,93 plus 12,63. Therefore, this is the bracket we want to work with. So this is 63,93 minus 12,3. So this gives us 51,63. Then we've got 63,93 plus 12,3. 63, sorry. I think it is on column up. Let's think about it again. This is 63,93 minus 12,63. Okay, that's 51,30. And then we go back. Actually, I should have just changed the sign only. 12,63. So this gives us a 76,56. Okay, so here we can say, therefore, how many are these? Now we look. We want anything below 51,3. So 51,3, 51 qualifies. Okay, 47 qualifies, and 46 qualifies. Because the length can carry a decimal, right? So good. And then anything above 76,56. So 74, yeah, 76,56. 77 qualifies, 80 qualifies, and 86. So there's going to be 6 trees. Therefore, 6 trees have heights that are 1 standard deviation outside the mean. All right, good stuff. So guys, this is very easy. not complicated at all. All we have to do is just to answer the questions, okay? We just have to answer the questions. So when we are told to show the workings, we need to show the workings, okay? So this one gives us a mark and that one gives us a mark. And the final answer 2 marks, okay, I suppose. That should be 4 marks. Or we can say 1 mark for the final answer and then 1 mark for the method here. Yeah, maybe it makes more sense that way. Right, so that's it, guys. That's it. So this one, we don't have doubts. We got full marks here. I'm not sure about the previous question. The last question is a bit strangish, but understanding a little bit should not be a problem, you see. Okay, guys, let's chase this one. Maybe let's just take down at least 1 analytical geometry question within this hour. And I can tell you guys, if you can pace yourself nicely to finish the first 4 questions in the first hour in the finals, and you know that you've done well in all of them, you're going to cruise to the end, because paper 2 tends to be longer. All right, so we're done with that, guys. Hopefully you have understood the analysis. Now, question 3. Apologies, guys, for my table. It makes some noises in my chair when I move. I'm one guy who doesn't sit still. Right, in the diagram, AD and F are vertices of triangle ADF. ADF. The equation of AD is a half of x plus 6 AD. So of course we can see the y-intercept, but we're not really interested in it. But perhaps the x-intercept would interest us more. When we make y 0, this is minus 6 times 2 becomes minus 12 and 0. At least we need to know what we can do and do it quickly, guys. So that's about it. And then of course this can give us the angle of inclination of that line, the gradient, right? And then what are we told? We're told that this line AD cuts the x-axis at C, so that's why we worked out that C as the x-intercept. B with coordinates minus 4 and 4, a point in the second quadrant, is collinear to point C. A and D, right, lies on DF such that BE is parallel to the y-axis. So any line parallel to the y-axis is essentially perpendicular to the x-axis. So we know that indirectly we are told that this is a vertical line. Ash, come on, app. Don't start fighting. Right, so this is 90 degrees there. So this is good. So this is a perfectly vertical line, that BE, just like the y-axis, okay? AF cuts the x-axis at G, which is 6 and 0. Okay, it's indicated. BG is drawn, okay? The equation of DF is 5y plus 2x plus 60 equal to 0. So this one. So technically, that one at this point will give us the y-intercept, which we don't really have much interest with it. So it says, folks, D remains elusive for now. And oh yeah, it's not quite elusive, but we know that we've got the equation of line AD as well as equation of DF, so we can solve simultaneously. So we will be able to solve it. Nice. But E is quite elusive at this point. Not elusive exactly. There's something. If this is a perfectly vertical line, the y at B is going to be the same as the y at E. So this is minus 4 and some y value. So it's not entirely elusive. Now when you take that minus 4 and plug it into the equation of DF, we will find the y value. So even this guy, we can work it out. So this one, at this stage, we don't have enough information. So we don't know what to do about it. And A as well, we don't have enough information. So we don't know what to do about it. Okay. So at some point we realize that we need more information. So the first thing that I do when I know I have points I have not quite uncovered fully, just skim and scan the questions and see what I need to do. Calculate the gradient of BG, easy. This one is in the bag. Show that BG is parallel to DF. Okay, that can be done because we just need to show the gradient of DF from that equation. If they are equal, then the lines are parallel. And then calculate the coordinates of D. We saw that we can work it out. Calculate the length of BE. We can find the y value at E, and then we can essentially calculate that vertical line. Let J be, okay, these kinds of questions that start singing, we know they're going to waste our time. We start with the ones that we can handle and get those marks as quickly as possible. Now, we need the gradient of BG. So this is going to be y at G minus y at B divided by x at G minus x at B. So y at G is 0 minus 4 divided by 6 minus 4 is going to be plus 4. So technically this is going to be minus, this is 4 over 10. Now 4 over 10 is basically 2 over 5. Okay, so this is a ratio, so we leave it as it is. Okay, substitutions answer, provided the substitutions only earn a mark if we have shown the formula. No formula, the substitutions lose the mark, okay? You only get the mark for the answer, so please guys don't lose marks. You see, easy questions, the strictness is super. So there is no complacency accepted there. Show that BG is parallel to DF. Okay, we know that DF is given by 5y plus 2x plus 60 equal to 0. This implies that 5y is equal to minus 2x minus 60. You can say therefore y is minus 2 over 5 x minus 60. You can say therefore the gradient of DF is minus 2 over 5. So if that's the case, we can say therefore indeed BG is parallel to DF. Okay, they have equal gradients. Okay, of course you can say it like that, or you can say MBG is equal to MDF. You see, lines that have equal gradients are essentially parallel. The question said show, so we need to see everything, guys. You start jumping around, you die. Okay, so what is important was this, and then to justify the conclusion. Although it's given, but we have to justify it. Okay, right. So 3.4. No, 3.3. So now we need to solve for the coordinates of D. So this is easy. We saw that at point D, we know that the equation of the other one, half of x plus 6 is equal to, we can take this one, manipulate it as well, and say this is minus 2 over 5 x minus 16. We're solving simultaneously here. There's no issues. Then we move that to that side, so this becomes 10, and then we cross multiply, we get 4 plus 5, it becomes 9 over 10. But again, guys, don't abuse your brains. Do whatever you can. So this becomes minus 66. Right. So we can see therefore that our x is going to be a negative number. So we just multiply that by 10. And then we divide that by 9. And it gives us something I don't know. Did I do the right thing though? Hey. Sometimes it's easy to not do the right things, you see. You need to be very, very careful here. Okay. Yeah, if we move that there, then this one becomes 66. So minus 66 divided by 9 over 10. Oh, no wonder. I'm not on computing mode. Dangerous thing to do. Let's do it again, guys. So we've got 0.5 plus 2 over 5. This is 9 over 10, okay? And then I've got 60 is 66 now. And then we say this thing divided by 9 over 10. 9 over 10. I'm losing time and I don't want to, guys. So this one gives us a minus I don't like what I'm getting. 220 over, this is Obajo, it's Obajo. This is 3, okay? What is that? This is like 73. That's outrageous. It's not possible. Did I mishandle some digits here? Yes, I did. Technically 60 was supposed to divide 5, okay? Yeah, what? So checking that things, yeah, this one was meant to be 12. Okay, so you see incorrect manipulation. Yes, it did not affect the answer at the top, but it definitely does kill the answer at the bottom. So stay awake, folks. Stay awake. As you can see this. But again, you will see the answer, like 70. And we're looking at minus 12 here. It's not possible. Even though it's not drawn to scale, we cannot accept it. So minus 12 minus 6 is minus 18. Yeah? So let's see again. Minus 18 times 10 is 180 divided by 9. It gives us minus 20. Okay? If we're sitting at minus 12, reasonable to 20 there. So that's the 1, guys. And therefore, y is, we can say, a half of 20 plus 6. What is that? This is minus 10 plus 6. This is minus 4. We can say, therefore, point D is minus 20 and minus 4. Okay, cool. That makes sense. It's a point in the third quadrant. And given the distances that we see there proportionately, it should be okay. As you can see, guys, if you stay awake, you will never make mistakes that you will not see. But don't rush these things too much. Try to pace yourself in a manner that makes it easy to get stuff done without too much problems. Right. So the method, and then the x value, and the substitution, and the answer. But remember, the question said coordinates, so we need to see that ordered pair to end the last mark, right? Easy 4 marks after all. Easy 4 marks. So we've got 3.4. We need the length of BE. So we know that technically the x coordinate at E is the same as the x coordinate of B. We know that with BE parallel to the y-axis, this is a vertical line. This is the case. So we can say therefore x at E is going to be minus 4. We can say then we know that E at this point is such that what was that equation again? Okay, we can just go straight to it. It's such that 5 into x is minus 4 plus 2 5y plus 2 into minus 4 yes, plus 60 is equal to 0. So therefore y here is, now this is minus 8 plus 60, so this is minus 8 plus 60 gives us 52. So this becomes minus 52 over 5. Okay? And that stays like that. And unfortunately, there's nothing else that we can do here. Alright, so that's what it is. So we can say therefore the coordinates of E is minus 4 and minus 52 over 5. Okay? Right, I hope this is not a mess. Alright, as you can see guys, I kind of slowed down, but I should have been done with these first 3 questions at least, in fact 4. But again, you don't want to be too fast and end up losing marks. Now what do we do guys? We know that therefore BE is going to be y top, which is 4 plus 52 over 5. So this is 20 plus 52, right? That's 72 over 5. And of course, that is a distance, guys, so it is safe to write it nicely. This is 14,40 meter. Is it meters? No, units. So a distance is normally presented like this. We never present it as a fraction, but I don't think there would be a problem if you did not. But remember, if you go to decimals, you have to add the 0 or else you'll be dead, because we're strictly told 2 decimal places only. Alright guys, so we get a mark for this. It's very important. Right. And then we get a mark for this substitution. And we get a mark for this y value. And we get a mark for the answer. Okay. As you can see, it's a very spotted type of a thing, but hey, it's done at the end. Alright, so let's deal with the last question. So this is 3.5. So what is it saying? Let J be a point in the third quadrant such that DJEB, so D, if it is in the third quadrant, so it's going to be, if it's here, then it can be anywhere. How to save it? Let J be the what? Be a point in the third quadrant such that DJEB. In fact, I almost assumed something. That's why I said puppy. In that order, forms a palm. Okay, if we're forming a palm, that was a good assumption. So we know that, okay, we can just say, okay, parallelogram, 2 opposite sides should be equal and parallel. So we can take that and move it here because we're told DJEB. And stuff like that, and stuff like that. So we've got this one. It's nice and rainy outside. I love the rain. But I want to be driving when it rains. Alright, so this makes our, what you call, our point J to be that point. And of course, it is x is to y. Sometimes you may have to think about how to find those coordinates. But remember, we were not told that it was not indicated, so we need to show it that this is a construction. But a parallelogram, we know the lines are going to be parallel to each other, like that. And they are not just parallel, but they are equal in length. Okay. And then this one should be parallel to the other one. And not just parallel, but equal in length. Okay. So that's properties of a parallelogram, right? Right. So what else are we supposed to do? We need to calculate the area of the parallelogram. Okay. Made it easy for us. So technically F we don't need to find A, so we get away. All right, so technically, guys, if this is a parallelogram, we know that these two triangles are congruent. Okay, these two triangles become congruent. All right, so we look at this lovely triangle here. We were told that this line is exactly perfectly vertical, and we calculated its length, so we can treat that as the base. But what we can do this. Get ourselves we can get ourselves a height of some sort, you know. Can get ourselves a height of some sort, but let's break it up before we go in there so that it can suit us. So we can see that, what if we draw a perpendicular height through this vertex? You know, we can do it. And that should be perpendicular to that line. Okay, this is a height, we can call it H. So we know that these two triangles are congruent. Why? Because we know, guys, that the opposite angles of a palm are equal. So that angle is going to be equal to that. This one is equal to that. These are alternate angles. As well as that angle is equal to that. These are alternate angles. This side is common to both triangles, so they are equal. That side is equal to that side. They are equal. That side corresponds with that side. So can you see, when all sides and all angles are equal, those triangles are congruent, meaning they have the same area. So we use one to solve the other. Now we found out what were the coordinates of D, right? The coordinates of D were -20 and -4. So we know that, okay, technically this height H is going to be the difference of the x value at B and the difference of the x value at D, because it's a perfectly horizontal line. It's going to be parallel to the x-axis. Alright, so there's so many parallelities here. So a lot of questions could have been constructed here, guys, like proportionality things, you know, proportionality theorem especially. You know, things like that. Anyway, let's get to business. Right, we can say in triangle B D E. So you can say C sketch. Of course, I do believe that you guys are given a diagram sheet where you can annotate and submit with the answer book, all right? Because this is very important. And then of course you just don't want to explain too much, that draw this height and what. You just show the sketch and someone will understand what's going on. We know that the area, so let's just say here, area of DJEB is going to be equal to 2 times the area of triangle BDE. then you can see sketch. Okay, meaning for the other details, because I mean it gets boring to say everything. So this is what is going to happen: half base times height. So this is a half into the base. We already calculated it. This is 14,40. The height, we need to showcase it now. It's going to be x ahead minus the x before for that horizontal line. Okay, so there it is, guys. So I've got 2 into 0,5 into 14,40 into basically 24. Right. So this gives us a 345,60 square units. Okay, so that's what we get. Of course, guys, sometimes it can be a disaster, sometimes it's not. So I find that one a lot easier. But again, guys, there are many things that one can do to sort of like sort this thing out. At the end of the day, I don't think it's too much to ask, you know. I think it's not a lot to ask. Right, I'm thinking of treating this as a trapezium. Would it work? Because it has two parallel sides which we have the lengths of, but I don't think it's gonna give us the accurate answer. Why not though? Let's not waste time. It is done, guys. So basically this is very important. This calculation is key. The general substitutions, the final answer in the correct manner and with the units in the correct manner. So that should be enough, guys. Of course, you are free to do anything that comes to mind as long as it will work. That's not a problem, you know, because some people may actually be looking to find this angle, you know. Again, we know that this is 90 degrees. We can use the angle of inclination to find that in that small triangle. And then we use the area rule. Of course, need to calculate that length. I mean, it's up to you. But usually the easier route is the best route. Because, again, time is a factor in the exam. But when you're practicing, you can explore all your options so that you are comfortable. And then this makes you sharper to decide better as to which battles to fight. All right, let's move on, guys. 16 marks in the bag. Analytical geometry is fairly easy to pass, guys, even with the higher order questions not answered fully. But an attempt at them is better than not trying them, because you may score some marks there. Okay, let's go through this one. Question 4 reads, in the diagram, the equation of the circle with center M is given like that. So essentially this gives us the coordinates of the center. So this is going to be -3 and 4. Okay, nice. And the radius is the square root of 26, but it doesn't help us much at this stage. PMR is a diameter, so this is a straight line, okay, of the circle. Right, the equation of the tangent, QRS, if this is a tangent, then this says we have 90 degrees here. Tangent always meets the diameter at a right angle. Okay, so this is already telling us that we have a right angled triangle. So any trig ratios can come in here, or Pythagoras. Right, the tangent to the circle at R, we are given the equation that it is -5x plus k. So we've got the equation, but wow, I just see something strange. This is not correct. It's not correct. So this is y, this is x. Okay, somebody was sleeping there. Anyway, q and s respectively are x and the y-intercepts of QRS. And then of course, if this is the x-intercept, we know that it's some x value and 0. Now we need to think about how to find our x value there. Okay, and s is very easy also to predict, because s is basically 0 and some y value, but now the y value there is exactly the k value, which we don't know. All right, so that means we need to think about getting that value. All right, that's what we have here. PWVT. PWVT is a straight line. Okay, it's a secant. Sometimes that statement can be given as a secant. Then we actually know that that is a straight line. That's the most important. Okay, with y-intercept at w, okay, now it's going to squash our diagram. We leave it alone. And the x-intercept at v, we may want to entertain that and say v is basically some x value and 0. Again, we need to think about how to find the x coordinate there. All right, so r is also an unknown point. So we know that r is basically some x value and some y value. So we need to think about how to get both those values. Now, t is also presenting a situation where we don't know how we're going to get around that business. Point P as well, x is to y, and we don't know what we're going to do. So usually with this question, this is somewhat the common scenario where we can't have answers for most of the things. But now we need to think, how could we do this? Well, we need to see what we can do with what we have. First and foremost, we've got the equation of the circle, and we've got the gradient of this line, and it is perpendicular to diameter. So technically, we can get the gradient of the diameter and use this point to find the equation of the diameter. Now, from the equation of the diameter and the equation of the circle, we solve simultaneously. It gives us point R, right? Now, we can get the coordinates of point R. Once we have the coordinates of point R using the midpoint, because these are already, we will be able to get the coordinates of P. So in essence, we can solve for P. With difficulty, yes, but we can. R, yeah, the same. And since we can find the coordinates of R, if we plug back into this, we can find K, which is the y value at S. So we can actually solve for S as well. And once we have the equation of this line in full, it will help us to solve for the coordinates of Q. Okay? So it looks like we can win, actually, although with a bit of difficulty. Okay, that's it for now. That's all we have for now. I'm trying to think, is there anything more we can do? Not exactly. So this V remains elusive, T remains elusive, W remains elusive. Okay, unless we can know more. Maybe we know an angle here. And then if we can know that angle, maybe we can work out, that angle of inclination. Then it can give us the gradient. With a point, we can find the equation and then find this. But it's just going to complicate our lives. So at some point, guys, when things don't seem to work out, you just go for it. Okay, so 4.1. Of course, you can skim and scan the questions, but at times, you don't want to waste time. It says, write down meaning no justification. Coordinates of m. M is -3 and 4. So we're getting 1 mark from the equation. B, the length of the radius. We know that the radius is going to be the square root of 26. Right? Right. So that's it. Just say that units. 1 mark from the equation, right? So we've got 4.1.2. Says determine the equation of the diameter PMR. So we've got a plane. We know that the gradient of PMR times the gradient of QRST should be -1. Why? The tangent is always perpendicular to radius, okay? Or we can say diameter if we will. Okay, now this implies that the gradient of PMR into, we know that this one is -1/5 from its equation is equal to -1. Therefore, the gradient of PMR is basically 5, okay? That's a fairly steep gradient, so we can accept it. We can say then PMR as a vector is going to be y equals 5x plus c. Now, we use point M, which is -3 is to 4. So this means 4 is equal to 5 into -3 plus c. Therefore, c is, this is -15, it becomes 15 plus 4, it gives us 19. Therefore, y equals 5x plus 19. Nice and easy, guys. So most important here for these 3 marks is the gradient, the substitution, and the answer. But I feel this statement is important because without that relationship, we would not move that far. But again, examiners hold their discretion in any of this. They can decide where the marks are to go. But yeah, as a student, please cover all these bases, because should it happen that you make a mistake along the way, if the marks are to be given, because you don't know what the marking guidelines look like, and therefore you may find yourself scoring 2 marks, sometimes. Even when you watch the rest of this, it can happen. Right, so we've got 4.1.3. So 4.1.3, we need the coordinates of R. Okay, we know that these are free 6 marks. They look scary, but we have a plan now. So we know that R is a point such that the circle x plus 3 all squared plus, where we see why we put 5x plus 19, then -4 all squared is equal to 26. We're solving simultaneously straight up. So this is basically x plus 3 all squared plus 5x plus 15 all squared equals 26. FOIL, we get x squared plus 6x plus 9 plus, this becomes 25x squared plus 5 by 15, that's 75 by 2, that's 150. X plus 15 squared is 225 equals 26. Right, we go on. So x plus 25x, this gives us 26x squared plus 6x plus 150, we get 156x plus, now we've got 9 plus 225, this gives us 232, right? 234 actually. Alright, how come I didn't know this? Then we subtract the 26 when we transpose. We want to move quick, guys. This gives us 208. That is good. So can we divide by 26 perhaps? Let's try. So this is going to be x squared plus 156. Let's see, 156 divided by 26 is 6. Let's see, maybe 208 can do it as well. Divided by 26, it's 8. Okay, cool. That makes our lives a lot easier. This implies we are on familiar territory now. So this is xx plus 4 plus 2. So we can say therefore x is minus 2, or x okay. Now we need to look. So if we draw a vertical line through the center like this, not exactly vertical, right? So we can see there that this is minus 3. So r is before minus 3, or is to the left of minus 3. So that should be minus 4. So we can say, well, therefore x at r is going to be minus 4. Right. Right. Now, where is it minus 2? Is it P? Well, that's a point before. Can you see? That would be minus. That would be the x-coordinate at P, the minus 2. So this is why this thing gives us 2 values. So we need to think about what is the other one. So that would be for P. Okay. Nice and easy. So guys, we need to find y. So we can say this means y is going to be equal to, we take the easier one, 5 into minus 4 plus 19. Now this is minus 20 plus 19, which gives us minus 1. You can say therefore r is the point minus 4 is to minus 1. Okay, that makes sense in the context of the question. Okay, that was a bit heavy, but again, this is a standard simultaneous equation you sometimes get in question 1 of paper 1, so it's not that bad. Right, so the substitution, interesting. Now the expansion, contraction, wara, I would say to get the equation in standard form is key. Whenever we factorize, this is very important to get the x value. See, 4 marks for that. And then, of course, this one and that 5 marks. But we still need to present the answer like that. So how many marks? 1, 2, 3, 4, 5, 6. Yes. Yes, 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 yes. So 4.1.4 says we need to calculate the value of k. So it's easy. We know that y is equal to minus 1 over 5 x plus k. So with our newly found e, which is minus 4 and minus 1, minus 1 is going to be minus 1 over 5 into minus 4 plus k. Therefore, k is, so basically, guys, this is going to be 4 over 5. When we transpose it, it becomes minus 4 over 5, okay? So we've got minus 1 minus 4 over 5, okay? So this gives us minus 9 over 5. Okay. So this is basically 1,8. So it's less than the y value at r, but not so far. So yeah, not so bad. Not so bad. So we can accept that value of k. Easy. Easy. So basically it's substitution and answer. Okay. Nice. If not nice, it's nice. Yay. 4.1.5. You see, the analytical section, guys, takes time. So sometimes it's one of the sections that need to be respected. You cannot rush through it. In fact, the bulk of paper 2, you cannot just rush through it. You just need to be reasonable with time. Okay. If OWV is 11,31 degrees, where is that? OWV. So this is this angle over here. It's this angle. Okay. So if it is that value, we need to prove that WSQ WVSQ is a cyclic quad. Okay. So we need to at least draw the structure so that we can see it. Alright guys, so there's our structure. So we can see that, okay, this is the structure that we're supposed to deal with. Now how do we prove that this thing is a cyclic quad? Now the first thing we need to ask ourselves is, why were we given this angle? What is it in this quadrilateral? You can see there's a line here. It becomes a diagonal of the quad. Okay, it's essentially a chord in the circle. And this, essentially this chord, if we're saying there's a quad, there's a circle around here, subtends this angle. But now this chord, if we follow it, this forms what looks like a bow tie. So this means for us, we need to prove that that angle must be equal to that, because if that, this would make angles in the same segment subtended by chord VS. If we can prove that these are equal, then this is a cyclic quad, meaning there's a circle around this quadrilateral passing through the vertices. Okay, easy. So all we need to know is perhaps to name this angle. Maybe we can call it alpha. Right, so we can say here, let angle OQS equal to alpha. Of course, we know, guys, that this angle of inclination of this line QRST would have given us that angle, but that is vertically opposite alpha, so that's why I'm focusing on that alpha straight up. So we can say such that all we know, guys, is that tan alpha is going to be equal to is going to be equal to the absolute value of the gradient of QRST. Okay, the reason is I don't want a negative value, so I'm trying to avoid it. So this implies that tan alpha is going to be the absolute value. What is that gradient? What was it? So this was minus 1/5. Ne? So this implies that tan alpha, when we say absolute value, it comes out positive. We can say therefore alpha is going to be the arctan of 1/5. Okay, which gives us whatever it gives us. Yeah, one. Yes, shift 10 for 1/5. So this gives us 11, to 2 decimal places 31 degrees. Indeed, this proves the point. So from here we need to state, you can go, therefore angle alpha is equal to the angle, what was it, OWV. Okay, you can say each each equals 11,31 degrees. That's the only reason they are equal. And if this is the case, this makes the angles in the same segment for that to be a cyclic quad. We can say, therefore, indeed, WVSQ is a cyclic quadrilateral. Quadrilateral. Reason? This becomes now the converse of angles in the same segment. Because we first proved that the angles in the same segment were equal. So conversely, that structure should be a cyclic quad. Okay, guys, don't think Euclidean geometry is only gonna happen, in Euclidean geometry section. And remember, even this method of calculating the gradient using analytical geometry, it can be the way to prove this in the original section. So this is just to show, guys, that maths cannot be quarantined into one spot in a paper, in a maths exam paper. No, it is not. This is why I'm against too much rules. Yes, we need rules, but too much of them, they kind of cage the subject and they limit the understanding by a student. All right, guys, so this is indeed, I think this is key. But remember, when we use an angle alpha, we need to have introduced it and even annotate the sketch to show this, okay? And of course, how many marks we were scoring here? 4. Okay. 2, 3, and the last statement, basically the reason. Okay, so that's how we score those 4 marks, guys. Again, you can see these are easy marks to get, right? Right. Now this question was heavy. 4.2 says, prove that the radius of the circle having this equation never exceeds the square root of 13, meaning that's the maximum. So that means the radius here, the maximum of the radius of an equation like this is root 13 for any value of theta. Again, as you can see now, trigonometry has come in here too. So this makes this a higher grade question, a true higher grade question. Right. Even this one is a higher grade question. All right, so there's always 2 or 1, but it's never more than 2, okay? So at least you're not going to be percussed too much. Okay, let's see. What are we supposed to do, guys? This is an equation of a circle expanded. So we need to contract it to define the radius, isn't it? So we complete the square here. So we can see here, did it say prove? Okay, once we are told to prove, it's more like calculate. We need to show everything. So again, pay attention to the line of questioning and understand exactly. Once we are told to prove, we need to show every step. Because again, a proof though can be by some form of a determination. So sometimes not that heavy, but we need to be reasonably elaborate. So let's start. We are given x squared plus. Now what I like to do, I bring in the thingy. So this is 4 cos theta times x, because we want this equation in standard form when it is expanded, right? So this is going to be y squared plus 8 sine theta times y. So plus 3. Okay, let's just start there. Just make everything look all right. So the next thing, guys, we need to show that we are going to complete the square. So here we can go about it fast. The sign between these terms is good. Now we just half the coefficient of x. So this is going to be 2 cos theta, and then we square that, plus take y and then the sign between them, and we just have the coefficient of y, so this becomes 4 sine theta all squared equals minus 3 plus, we take that one squared, so this becomes 4 cos squared theta plus this one becomes 16 sine squared theta. Okay, easy. Now folks, what was our interest? The radius. The radius is the square root of this thing. That's what we're interested in. So we can say this implies that the radius r is going to be equal to the square root of that shenanigan there. So this is minus 3 plus 4 cos squared theta plus 16 sine squared theta. Okay, so now we need to keep moving, guys. This means our r is going to be the square root of, now this means we need to play trig identities, because this means this whole thing needs to be at least a trig function, because if we're looking for a maximum, we know we can actually determine the range, and the range will tell us maximum and minimum. So this is minus 3 plus. Now I'm thinking we can change cos to sine, since sine has a big value there. So this is fine. So this is 4. Using the square identity, this is 1 minus sine squared theta plus 16 sine squared theta. Okay, that's it. So let's see, this implies that r is equal to the square root. Now we FOIL this out. This is minus 3 plus 4 minus 4 sine squared theta plus 16 sine squared theta. Okay, it looks like I'm cluttering things here. Let's give some space here. Now 3 and 4, this simplifies to just 1. Plus 16 minus 4, this is 12 sine squared theta. Okay, this is outrageous now. Alright, so this is getting there somewhere. But remember, for a trig function, we don't know the maximum of a square of the function. So we need a single trigonometric ratio or function before we can talk maximum and minimum. Now this means we need to play here. So of course, the way I know how is this, thinking of double angle identities. So this is 1 plus 12, we can split as 6 times 2 sine squared theta, because we know we can recognize what this is using identities. So again, you see logic, guys. As I always show you guys, learn how to split things conveniently. Now we know, folks, that cos 2 theta is basically 1 minus 2 sine squared theta. If we want to isolate this guy, we can transpose it to the other side and then cos theta to the one side. So this means 2 sine squared theta is 1 minus cos 2 theta. So that's what we need to do here. So this implies that our r is the square root of 1 plus 6 into, this time it's going to be 1 minus cos 2 theta. Okay, now that's better. So we sort it out. R is equal to the square root of 1 plus 6 times minus 6 cos 2 theta. Now we can say here, guys, indeed this implies, okay, maybe we can say therefore our r first and foremost is equal to, so to write it nicely in standard form, this is minus 6 cos 2 theta plus 7. Okay, so this is essentially trying to find a situation where we've got y is equal to minus 6 cos 2 theta plus 7. Can you see this is in standard form, a vertically shifted and reflected graph, of course, with the double angle, meaning we've shrunk even the horizontal extent, or at least the period has been increased. So So now we know, guys, that technically the maximum here is going to be the absolute value of the function, right? So maximum is going to be the absolute value of minus 6, which is 6. So that would be the maximum of this function for any value of theta, for that matter. Of course, going to be some specific values, but at this point, for any value, when you say maximum, whatever the value of theta is going to be 6. But then this graph is moved up by 7 units, so we add 7 to it. So we can say, therefore, the radius maximum, because this is, when we say it does not exceed, we're talking about maximum, implies that we've got the square root. Now it has to be the maximum of this. This is going to be 6 plus 7. Therefore, the radius max is indeed equal to the square root of 13. Right, units at the end. Right stuff. So we need to say that statement, max or maximum, guys, because otherwise, if we don't go maximum, then we're not doing anything. As you can see, guys, a bit of trigonometric work in analytical geometry. Started off by analytical ways and then down. So these questions are just trying to showcase that these things can come anywhere. So please, guys, be ready to do things, okay? Be ready to do things. I kept on saying this, I don't know how many times, that students need to be aware. Anything can be brought anywhere in any light or sense. Your job as a student is to know everything. And this means when you're preparing for paper 2, you still study paper 1, okay? Calculus and all that, because you may deal with derivatives at some point, you never know. And optimize is essentially optimization, but it does come more often in the trigonometry section, but you never know. Since we're talking maximum here, if this thing became an algebraic expression of some sort, we would have to take a derivative, you see. So get ready for these things, but this one was a beautiful question. Whoever thought of it is a true mathematician. Yeah, it's making me excited, but again, I don't know how you guys fared on this one. Anyway, first and foremost, to write this equation in this form, the what you call, technically the right hand side and the left hand side is key, see, and essentially taking down the radius as a square root, that was key, ne? Then using the square identity there, remember we always get a mark for that, and then using the double angle identity, that gives us another mark. But I think to know that the maximum is going to look like that is key. The answer was already given. So how many marks now? 1, 2, 3, 4, 5, 6. So we can say 1 mark for this way of writing as a whole. Okay, because all of these other steps are critical. Expansion is not, but the work is the work. Alright guys, so that was a very nice question, but it could have caused some palpitations, chest pains in students who don't do due diligence. Anyway guys, let's move on. We can't get stuck in the past. Whatever sub-stories we have about this question, we just gotta move on. Don't sit in your sub-stories too much. You will destroy yourself. You will do self-destruction. So sometimes move on. Better luck next time, you see. But again, learn from the experience. Don't shy away from it, because if you do, you're gonna get tripped again and you will fall. But if you learn exactly how you fell and what was lacking from you, and you appreciate it without being in denial, I promise you, come the next problem, you'll be ready. Even the first time you see it, you'll be ready to know what to do. Right. So we are in the algebra section of paper 2. So we are given cos 16 degrees is equal to k. So obviously, guys, we show this as a ratio, right? Because we know we will be told a very lovely story not to use a calculator. So automatically we know what to do. Now, now guys, we know that we are dealing with an acute angle. So an acute angle that is positive is in the first quadrant. So there's no doubt about it. So this thing is here. Mona, 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 mona. Mona, mona, mona. Mona, mona, mona. Ketladula kirabela. Ketladula kirabela. Birda, birda, birda. Mona, mona, mona. I wena. Mona, mona, mona. Mona, mona. Ketladula kirabela. So obviously guys, we work out every angle that is possible. So 90 degrees minus 16. This is 74 almost. Yeah. Let me check. You see, sometimes things like these do the things that you don't want to do or that needs to not be done. So cos is adjacent over hypotenuse. So this is the standard circle. Yeah. It's the one. Now we know that we are interested in y. Straight away we know x squared plus y squared should be r squared. We know this from Pythagoras. Please guys, don't jump steps. Doing so is chicanery. Is wrong. So now move guys, asinaxesha lokuhlala singobantwana boka grade 10. Sivele siye straight xa sesibonakalise ngokwaneleyo siyibamba ngqo ezimpondweni, siyiphula intamo inkomo ngokwezixekela beqinini, iqonda njalo lento. So sibe sesiyayithatha le mpendulo yethu siyoyifaka ngqo phaya. The most important thing is to do this guys. Now why are we choosing the positive square root? Is because it's on the positive y-axis. First quadrant has the positive y-axis as its vertical. Now we are ready to hustle these ones. 5.1.1. It's always the case guys. Gonna use ratios, whether same function versus co-functions. We're gonna have to use a direct question. We may have to deal with identities, whether compound, double, or combination. It doesn't matter. Just know that question comes in three formats always. A direct question sometimes. It could involve the angle given or its complement, right? Because it's always on a right angle triangle. So its complement is 74 because those are complementary angles. It's either going to involve the complement or the direct angle. Maybe if we're given cos, we may have to find sine of 16, or maybe cos of 74, sine of 74. Then the second way is going to be asking you and I to handle this using co-functions or same functions, meaning reduction formulae. The third way is going to be identities, any of the identities, or even a combination of. Right. Now we have sine of 344 degrees. We know that this is the same as sine 360 degrees minus 16. How to say jonge? 360 minus 16. Yes. So sine in the fourth quadrant is negative, but once we see 360, that's same function, so we keep the sine function. So this is, see? Yes. So this one was using an indirect form, using reduction formulae. So this is going to be minus, sine is opposite, it's going to be the square root of 1 minus k squared, all divided by 1. So we simplify, this is basically just minus the square root of 1 minus k squared. This time we cannot move further here. Right. Of course, we're told to do this in terms of k, right? So essentially, guys, this reduction is important, but we need to see this. We need to see that, okay? Then we can easily say, yeah, the answer perhaps is important, but the third mark was actually working out the y value there. So that's the first 3 marks in the bag. Of course, this question can be rushed if one is clear. 10 of 106 degrees. What is that? This is the same as 10. Now 106, it's not going to be 180 minus 16, minus 16. So this is 164. What about 180 minus 74? 180 minus 74. It is 106. Okay. So this is basically 180 degrees minus 74 degrees. Can you see? This one needed us to think of the complement to sort this up. So again, this is the second quadrant. So 10 in the second quadrant is negative. So once you see 180, you keep the same function. So this is minus 10 of 74 degrees. Now from the statement, we know 10 is opposite over adjacent, but now the opposite side here is k. So this is going to be k divided by the adjacent side is the side on which the angle lies. Okay, so this is going to be the square root of 1 minus k squared. Okay, then we simplify this whole thing. It's going to be minus k all over 1 minus k squared. Now in grade 12, we don't rationalize the denominator. Of course, there's no need. If we want it to rationalize, we will force your hand and say, prove that 10 of 106 is equal to a rationalized form of this answer. But if you're in grade 11, let's just say grades 10 and 11 never leave an irrational denominator. So if you're a grade 10 watching this video and you watched up until this far, just remember, you are not allowed to leave an irrational denominator, meaning you have to rationalize the denominator. But in grade 12, we decide if we want it or we don't. So you don't have to. But if you did it, it's okay. But it doesn't give you extra marks if it is not a requirement. That's just the stories. So guys, this is good for me. The reduction and the final answer. Very important. Very important. Because to know that, we would need to add that 74. It is key. Okay, all right, okay. Right. You know, some students, I'm thinking about it now, some students may think of this situation. 10 of 106 is the same as 10 of 90 degrees plus actually 16 degrees. Ne? So 10 we know is sine 90 degrees plus 16 degrees, because we can't solve this one in grade 12 lately, but we knew that this thing would simplify to cot 16, but since it's in the second quadrant, it becomes minus cot 16. But I don't know why this was disregarded. It's crazy how South Africa sometimes adopts things. I don't know where they got from and why. I'm not saying don't get things from elsewhere, but why then do you change what we have instead of just adding to what we have? Why do you want to stunt our growth, people? So this one goes to cos 16 degrees divided by, this one becomes minus sine 16 degrees. And of course, from here, you know, it's going to go there and go down. So that's an alternative route for those students who can imagine things and are comfortable with trigonometry. I actually enjoy trig on this part, the one part that is boring me in trigonometry. Stop ogering, man. I love trig, but hey, I love Euclidean better than the rest. Maybe my second one that I would like is analytical geometry, and then trigonometry. I can tolerate it. Maybe I should say so. I tolerate it, but I don't like it. I am lying. I actually am okay with it. You know, kubani maskana want to gone, but I'm not man. I'm not in them tand, I'm not in them zonda, I'm not a foot in them zapogela, or kanye in them zapogela, nje upaya nje strokeleng. It's just, you know, yeah, I think it tricky challenge. But Euclidean, yo, the curves must. I like curvy things. And of course, analytical is a bit of structure, angles, and all that. You see, there's something to see there. And of course, algebra. Okay, trig is not bad because there are some curves there that we see, but those ones, man, that's quite dynamic, man. It's static, man. It's funny just chincha, man. It's a sense of be excited. Yo, he went tinimbo. Tinimbo sans siqhela kabi ngabantwana abancinci bothetha nabo. Hey, ungalibali. Uthetha nepikinini apha. More than uthetha nabantu balingana nawe, man. Hey, sisiphaphela. Saba ngabatitshala abakenengqondo. All right, now cos of 8 degrees. It's always one of those crazy questions. Usually the one that involves identities, guys, we can essentially say there will always be a higher grade question there. That's going to demand a little bit from you, and you just have to give what is asked. So what is cos of 8 degrees? We can see 8 bafowethu uyafana uhlobene nalowa. Yayibona 16 umdala mncinci lwangu double, yayibona. So that means double angle identity is using 16. So in essence, we don't start here because we know that we want to reveal this later. But sometimes if you know, you can easily say whatever you want to say. I mean, there are many ways of killing a cat. So if you decided to go straight instead of going indirectly, because this is an indirect question technically. So for me, this is to say, let me just show you two techniques. You can just say cos 16 degrees is equal to 2 cos squared 18 degrees minus 1. That's the identity, right? But this time we're going to treat it as an equation rather than to solve one side. Because now our job is to isolate cos 18. So we do that. So we can say 2 cos squared 18 degrees is going to be equal to cos 16. I'm not 18, galo 8. Ish, cos 16 plus 1. Yabona? Size nayo kancane. We got cos squared 8 degrees is equal to cos 16 degrees plus 1. All divided by 2. Yes. Icho kaloku lento sibese sithi okay siyamazi ke ngoku cos 8 degrees xa sithatha square root izawuqala phaa laa nto ibe nje sizoba nobani cos 16 okay plus 1 all divided by 2. Khona enye into esingayenza andiqondi iphelile xa nje siyeka nje khona phaya. Yabo? Nice and easy, guys. Not a very difficult question, but this is skilled. A skilled substitutions. Is it substitutions? Aye. And go happy. The gymnastic, guys. The gymnastic of the square root and the substitutions inside, or whatever you call it. Substituting cos of 16 with K. I think so. This one is a strategic question, but the gymnastic of squaring is cool. All right. So this is how a student can go about business here. Or one can just go and say cos of 8 degrees is going to be equal to basically cos of 2 times 8 degrees plus 1 divided by 2. And then take the square root, of course. You can do it straight up, guys. You see, identities, you can play with it. No one is going to ask about it. So cos 16 degrees plus 1. But show that you are using double angle identities. At least we need to see this part before we start to see other things, because we need to understand what's cooking. And then we can come up to the conclusion that cos of 8 degrees is indeed K plus 1 divided by 2. Done. So this is still allowed, okay? There's no need to say you needed to start like I did, but the standard approach, just know that once you see half of an angle that was given, rather use an indirect approach, which creates nice equations that would flow nicely. But here, you can break your neck yourself here, not knowing what you've just done. But again, rough work is there for you and I, if we should choose the other things. Okay, guys, so let's get to BSF 80. So what is this BSF 8? Can we squeeze 5.2 here? So we have cos squared 180 degrees plus x into 10 360 degrees minus x times cos of 90 degrees plus x sine of x minus 90 degrees times cos of 18 degrees. Okay, so what is the question? Without using a calculator, simplify the following to a single trigonometric ratio. And remember, guys, a single trigonometric ratio must not have a square, not a square of a trig function or ratio. Not a square of a trig ratio, please. This is very important. I know grade 12s are complacent. Don't be. When we say single trigonometric ratio, it means the resulting function or whatever we get must not be a square, because that doesn't become a function. It's not a single trigonometric ratio. A square is not single. Ne? Yes. Sichatile isquare. Sizichatile. Ngabafana okay masingayi. Masingayi apho so offend abantu. Benza uthetha into ezaba offensive, but masiyeke khona apha nje. Ewe kaloku sifuna uba offensive guys, noba ke unfortunately singafuna uthetha inyani yabo. Ba ke inyani le bengandixelela yona. Qha izawukhubekisa abantu abathambileyo. What I just said, if you didn't catch it, I almost said something that's going to offend people. Well, people are so fragile and their egos are so easily bruised. I would rather not say what I was trying to say, because technically, as much as it is the truth, but nowadays with all this fragility and this petty sub-story type of behavior and this individualistic perspectives that unfortunately don't want to face consequences alone, but technically doing things alone, yeah, you will be labeled something you're not, just because you tell the truth as blunt and raw as it is. But hey, let's not get there. So just note this thing, guys. Note. This is very important. When we say simplify to a single trigonometric ratio, it means you cannot leave that as a square in grade 12. But in grade 11, unfortunately, you cannot deal with the square of a trig function better than just leaving it at it. So in grade 11, you are forgiven. In fact, the question should never even suggest that you are to simplify this to a single trigonometric ratio. It should just say simplify fully, that's all. But in grade 12, when we say to a single trig function or trigonometric ratio, you need to never have a square in the final answer, ever, of the trig function, of course, or trig ratio. Anyway, anyhow, we move, guys. This is equal to, so reductions. So this is going to be minus cos x all squared. Right, that's the third quadrant. So we're using reduction formula here. Three-step approach. I'm not going to tell you guys this. So this is going to be minus 10x times cos of 90 plus goes to minus sine x cofunctions plus. This one is in the fourth quadrant, so this is minus sine, minus cos x, again, cofunctions. If you don't know this, you didn't watch my videos in this channel. Well, I don't know uzokunceda kanjani xa nawe ungancedakali, ngoba kaloku awunothi i-channel i-rich kangaka ungayazi uba ireducwa kanjani negative angle in principle. That's an angle. Let me show you guys in case you are new to my channel. So this is 0, 90, 180, 270. But 270, sometimes we call it minus 90. So that little thing there, it says sine of minus 90 degrees plus x in essence. So what is minus 90? 270. Plus x, we're moving clockwise, anti-clockwise. So this means it's an acute angle from minus 90. So there's our x. Can you see? It lands in the fourth quadrant, but 270 or minus 90 means cofunctions. So that's why I know, okay? And that's why you should know. But there are many methods proposed for students to go around solving these. I also have suggested a lot in my previous videos. So I would assume you are a resident of my channel, and so you should know things. So this is cos squared x into, now 10, essentially this is minus sine x over cos x times minus sine x plus cos x. Right, we got cos squared x into, this becomes sine squared x over cos x plus cos x over 1. Right, siyabaxoxozelisa, sibafake emajukujukwini. Now when we solve this into a single fraction here, we end up with just sine squared x plus cos squared x. Again, you need to know how to deal with fractions, guys. Now we know that this is cos squared x essentially into, this is 1 square identity over cos x. Now this is a nice product that takes the square. So this becomes cos x. Nice and dandy. Can you see there's no square there? If there was a square, you would have to manipulate it using identities to get rid of the square in the final answer. Please, guys, don't leave things hanging. I know I have done this in the past, but kind of struck me when I've already done it that, hold on, I did not answer the question, and it's been a trend for a while after all. So as we can see, guys, we are growing together. We are improving our resolve here. Okay, let's not talk too much. So these reductions, folks, are important. You see, these ones. Already, guys, 5 marks in the bag using the quotient identity. Done. This one, done. This one, done. 1, 2, 3, 4, 5, 6, 7, 8. This is supposed to be 8 marks, man. Supposed to be 8 marks, man. There, dog. Giving us 7 for what? With 8 marks, this one. Never. Ndiyala. Aktua. Never. No less than 8 marks here. Ndimcela. Nikana bantwana imarks zabo. Okay? Kungenjalo ndizazozihluta straight, ndizazozihluthula. Because I'm a bully, mos. Yeah. I will bully you. Give the kids the marks when njalo sakubethekisa edongeni ngoqondo. Right. 5.3 says given cos 3 theta plus 7 theta over 5 theta equals 2 cos theta. So compound angle stuff. Okay. Cos 3 theta plus cos 7 theta divided by cos 5 theta must be 2 cos 2 theta. Right, so we are supposed to prove the identity. So we know that, guys. We look at the complex side kalok. The left hand side looks bit complex plus cos 7 theta divided by cos 5 theta. Now, folks, remember, you see this is 4 marks. These 4 marks can be actually hiding issues of very difficult stuff, but at the same time, sometimes when you look at the mark allocation, it says you should not actually work too hard. So it means be strategic and be very precise, because if you're not, you will end up where you don't want to be. All right? Okay, all right. Now let's study these things first. Inspection, guys. This is 3 theta and 7. What is the relationship between 3 and 7? This is 3 plus 4. Okay, no problem. Cos 5 theta, how is it related to the smallest? This is 3 plus 2, but now we've got 4 and 2. Oh. Okay, so this means at least we can get 3, and then we get here 3 theta and 4 theta. And 4 theta we can narrow down to 2 theta. Maybe it can give us something close to this, but I think the vibes are that, guys, we need to handle the numerator first. And we leave this denominator, because if we start working on both sides, this is complex, these are compound angles, they will have very ugly expansions, Because you see, this is going to expand to 2 terms, expands to 2 terms, so we end up with 4 terms in the numerator. So we're going to be overwhelmed. But at the same time, if we can say this is 3 by 4, this means we can hold on to U and hold on to U. Now in maths, guys, strategy is key, and again, precision. Don't jump around. 3-step approach. I showed you how to work things out. So let's say, okay, maske siyeke wena. Ungathi umncinci noko sakuyeka nje ukuhlala nje utanase nje asixelele into ezininzi. Wena umdala wena. Fanele ukwazi ukwehlukanisa. So this is cos 3 theta plus 4 theta. Right. And we said nawe umdala kodwa young adult nawe khawume kancinci nje sakhe sikuxolele nje, although singazokuxolela kwaphela, but maske sidile ngale ndala kuqala. Ngiyayifake ngokulento. Abantu abadala ngaba ba-accountayo, abantwana bayahlala noba bemoshile bayakhamisa, but umuntu omdala uzawublame abantwana ekhona kodwa xa bekusenzeka i-disaster sisibhanqisa. This is going to be cos of the first angle, cos of the second angle. Okay, so it looks like sizawukhala inyembezi apha. Sendiyazibona nje inyembezi seziyazehlela nje, sendiyinkamela ndilila ndingekabethwa. Ngoba iswazi sendiyalibona lifikile. mani wenza ntoni ngoku wena? Yabona ukutatazela konke or ukubona xa uthenjiswe isibhaxo ekhaya ufika sozichamela ungekathinto xa ephakama umzali utakele emnyango nathi strategic mntange nathi xa ndizawubethwa ndiqonda uba ndiboshile ndihlale ngasemnyango kuthiwa ngena uyohlala phaa ebusapho hayi ndiyapho ndihlale phaa emnyango ndiyazi uba xa iqala ishukuma uma-olas ntakile sanokwespring onqanda le esirhoxweni phofu ke bendinejubane bendingabambeki actually befuna bandirhare njengomvundla bekhona bazangivela emacaleni nangaphambili otherwise osangemva hayi bebona uthuli xa ingxaki ngoku ufuna ndiphinde ndibuyile endlini at some point so ke nokubaleka bengancedi ncam so i-olas laselingasasihluphi lithi mandileqe because ndandibashiye if akho mntu ozawundirhara ngapha nangapha okanye onejubane omdala bekuba nzima so ivele azithulele njengathi ndiyekile nam ndilibale gqiba tyiwe sapha socinga hayi sabethwanga vele ubone selibuya icango ngamawala xa uthi tshona phantsi kwebhedi sekuyorhudula iswazi phayana yes aziyakhala ke lapho into kubhutize benenkani engafuni ulila qha ke ndabona uba le nto ungalili indibethisa kakhulu wanaye ndathola esinye isibhaxo endandingasilindelanga ngenxa yongalili hayi ndabe ndinabona uba xana ndithi nje kusaphakanyisa iswazi ndivele ndihleli ndilile once kwenzela uba ndizobethwa kancinci yisi kube namaqhinga saqonda uba okay esi sibhaxo ndisavoida but yongenani ithi silimithe ke ngoku vele ndilile ndingabethwa uyazi uba ngelinye ixesha vele ungxoliswe nje kuphela ungabusabethwa uyidojile imbumbulu ndiyakuxelela nemetsi njalo apha funeka uvele ulile ndingekabethwa izawuvele ikuxolela imetsi kuyeke otherwise uqala ngokuqina ube ngumaqina sizakubulala izawuvele ithi for loo nto ukuthi awunambeko uselimbeko umthetho wakho awunambeko abantu abadala abazi uselimbeko umthetho wakho awunambeko abantu abadala awubazi. Right, now guys, strategy. So we can see that okay, this one is 3 theta plus 2 theta. This one is already 3 theta. We've got 4. We can split this one to 2 theta, right? Yes, so we can say this one using identities. This is a double angle. It's basically cos 2 theta times 2 theta. Sorry, cos 2 times 2 theta. So this can simplify. We can use cos here. So we can say 2 cos squared 2 theta, right? Minus 1. Because the reason why I'm introducing this, I want this cos 3 theta to multiply the minus 1 so I can get rid of the extra terms. You see, strategy. Sine 3 theta times. Now this is a double angle for sine, so this one is 2 sine 2 theta cos 2 theta, right? Kiona. Hayi nina khanime kancane nina siyeza kona andike nibe nikhula lapho so ndiqhasa masenibadala ndingazixhomi bantlami nizolimala. Right, so masiye ke ngo-cos 3 theta plus, we foil this out, it's going to be cos 3 theta times 2 cos squared 2 theta minus cos 3 theta minus, then what do we have here? Let me straight sine 3 theta 2 sine 2 theta cos 2 theta. See, this thing is overwhelming, guys. So it is best sometimes to hold on to other expansions because that's going to make you dizzy and you're not going to see your way. Okay. Right. This is equal to, now we can see the first one. No, not is by liability. Kudluka tsotsi. So spices. Asijonga futhi sibone ba hayi man. Cos 2 theta is common here. And no 2 common, so masijonge. This one is common to these two terms that survive the thing. And we've got cos 2 theta here, and we've got cos 2 theta here. So we can say cos 2 theta, come out, baba. So we've got 2 cos 2 theta. Can you see? Sesiyasondela. Sesiyasondela Jerusalem. We are marching over to Jerusalem. Yeah, Jerusalem. Jerusalem, we are marching over. So what survives here is cos 3 theta times cos 2 theta. Right. Minus sine 3 theta times sine 2 theta. That's what survives that. Factorization. 3-step approach, guys. If you become a friend of that technique, I promise you there's nothing you won't solve in maths. But again, it's not going to solve it on its own. You've got to recognize what to do. Meaning your knowledge needs to come in so we can see we have what we want. So this means our attempt must be to eliminate this big bracket. How do we do it? Sesiyabona jonga cos 3 theta 2 theta sine 3 theta sine 2 theta. Can you see this is the cos compound angle identity expanded? Now using identities we can shrink it. This is going to be cos basically 3 theta plus 2 theta. Because when the sign is negative, this one was added. Right. Sesiyawina. You see ke ngoku sithi naye lwa young adult ngathi san so yaphapha. Sesiyabona ngathi sowutshatsharanyana wena ngathi sozafumana i-go home situation. Yes, this one is basically going to simplify to just cos 5 theta. Sithi ya uphapha kakhulu wena denominator ngathi soyaphapha uhamba into zabantu abadala suka khane istumos. Yeah, let's need the blacky for the light is here. So cos 2 theta is the one, guys. So this is the right hand side. Thank you very much, comrades. It's been an honor. Can you see lots of work hidden by just marks to suggest that, hey, when most likely the examiners know the students are going to faff around here and probably not get these marks. So this is perhaps to protect you students by giving less marks because they know you're not likely to get it right. As you can see, you can piss your pants here if you don't confront this well. But I've shown you videos on the channel, lots and lots, even these higher order questions where I take it from the simplest part to the most complex part, meaning taking it from the right hand side back into the left hand side. That is the attempt to get you used to handling these complex situations like you see here. Because this will make you give up even on a standard approach. So getting comfortable with expanding things first, blow them up, then shrink them into something meaningful and get it done. So this is that approach, more like taking it from simple to worse and then simplify eventually. So if you don't take those tips, guys, and those little things, or at least you take them for granted, because I'm forcing you to know things and to know them well. And the 3-step approach, as you can see, is the key to all the troubles you will face in maths. But it's not an answer on its own. It is a framework upon which to build. Now, knowledge needs to be nicely, aligned there. All right, guys, before I talk too much, let's get these marks. Where are they? technically, essentially, whenever we do an expansion, because this splitting here is just to set up the mode, you see, when then select sithi hayi man xa sikroya enye identity phana siyayirhoya phana bese sithi sikroye nenye phana yabona 3 marks nje kanjalo. Now foiling and eliminase at this level we don't really care about it, but when we factorize by taking the highest common factor, this is mark worthy, right? Now technically shrinking this into cos of 5 theta, meaning using identities, that's a mark, okay? Now the elimination and the final answer is not big. Again, this was meant to be 5 marks, but at the same time, I agree, it is quite complex. I doubt students got this one in their majority. It would take a few who are really good and have been taught well, and they also did their part of practicing well. Those who do not will definitely buckle here. The only mark they can get is probably the first 2 marks, maybe. These ones are likely to be achieved, maybe the first 3. You see, sometimes this is what I like, because you can actually get the first 3 marks technically. I mean, those ones are easy to see. Then after that, you would get lost, I suppose. And perhaps you would lose the last mark. Can you see? You passed the question even when you did not really do so well. That's what I mean when I say, show your things. Show your things. You will be shown things too. So that's the correct labeling there. Now, folks, let's get to the next one. It says we need to determine the value of without using a calculator. It's just 3 marks. Maybe we can squeeze it here. 5.3.2. Now, we need to study this again. See, this was a higher grade question, guys. Higher grade. In fact, I think question 5 as a whole is a higher grade. So here, they were touching and pressing on your frontal nail. Now you decide whether your bones have not closed or not. If you're a baby, you'll seize. But if you are maqinas, you forgot to sell valegila, no bangacofa kangakanani, bayahlala. Determine the value of course, once this thing says hence, it means we're gonna have to use our identity here. So we can see that this is looking like the left-hand side, right, of our identity. Now let's try to find what looks like it. 67. But now we see that we've got 3 times a particular angle. So the smallest angle here, we need to divide it by 3 to see what it is, just to make it look like that. So I'm 67.5 divided by 3. It gives us 22.5. So this could be theta, right? So this basically 67.5 is basically 3 times 22.5. So that spells out 3 theta, okay? So technically we write the expression at first as it is given, cos 157.5 degrees plus cos 67. Can you see they pushed it ahead so that you can get confused a bit, divided by cos 112, like that. So we know that this, guys, is going to be equal to, we still need to showcase what is cooking here. We start with the small one, cos of 3 into 22.5 degrees. Plus, let's see, 157 in terms of 22.5, let's see, 157.5 divided by 22.5, what is it? 7 years. So this is cos of 7 into 22.5 degrees divided by cos, let's see, what is 112? 112 divided by 22.5. 112.5 divided by 22.5. 5. Phansi ndaquleka. Ndiphanse ndafa isiqaqa. Now, we know that the coefficients to our angles have come out, and now we know this thing is like that 1. So from here we know that this is going to simplify to just 2 cos 2 times the angle theta, which is 22.5 degrees. Yeah, this is now 2 cos 45 degrees. Rushapile, cos of 45 is 1 over root 2 kaloku mos. Yes, special angles. So as much as I hate to stagger my answers, so this is basically 2 over square root of 2, which is the same as just the square root of 2, right, when we rationalize. But again, in grade 12, this is good enough. That is good enough, so you can stop there. Okay, cool. So that is the one, guys. That is the one. That is the one. That is the one. That is the one. And of course, you can put it on the calculator if we are bilayelani. You can just do it and say cos of 157. I know I'm wasting time now, 5 plus cos of 67.5 divided by, but again guys, with this you need to check because it's easy to lose yourself here, make mistakes that go unnoticed, especially when everything flows from there. Then you end up with an answer that's convincing but it's wrong. So the answer I'm getting is 1,414213562. Let's see, what is square root of 2? Same stuff. So indeed our answer is correct. So you can check answers here to ensure that as you move on, guys, you're not dropping. Of course, students are more likely to get this one, but again, it takes precision and knowing how to compare and contrast, because if this part is missing, you are dead. Even the other one above, but this one already knew what we were going to, but this one, you can actually put a value here. Say just, when you check, just say x is equal to 2 degrees, right? Plug x here and plug x here on the whole thing. But then you have to be careful with the brackets and see what answer you get. If the answers agree, then this is a good reduction, irrespective of what the memo may go to. But this is good enough. As long as it is still a representation of what is above, you are fine. You are handled. You are definitely fine. Okay, guys, now, masmakishe 3 marks. Uncovering the secrets. The final reduction. The final answer. Whether this one, guys, or this one, it's one and the same thing after all. If you're grade 11, yes, we rationalize the denominator. But if you're grade 12, we don't actually care, unless we decided to say prove that that expression is equal to root 2. Then it's already saying you will have to rationalize the denominator. But we will say without a calculator, so that you don't come up with this one. You can't say cos of 45 is 2 root 2. No. 18 kanen. Konje, this thing becomes root 2 over 2. The moment when Kanje, you are giving the vibes that you copied, actually, because that's what the calculator does automatically. If you see money answer say rationalized, singayibonanga irrationalization, you are dead meat. Okay? Unless you can show us that circle with those root tones, then we will accept. But if we don't see that, let's go ahead. Guys, this thing is tiring. Anyway, let's finish up this question before I lose too much time. As you can see, this is quite labor intensive. So we need the general solution of this thing. So we've got 4 sine 3x plus 1 into sine x minus 5 cos x is equal to 0. We know that this implies that sine 3x is minus a quarter, or sine x is equal to 5 cos x. Right, so we can see that this implies that sine 3x is equal to minus a quarter. Remember, we need to sort everything nicely, so divide by cos here. This becomes sine x over cos x is equal to 5. Then we continue, sine 3x is equal to minus 1 over 4, or this is 10x is equal to 5. Now we are ready to do the gymnastics, so we know that 3x is going to be the arc sine of minus a quarter plus k times 360 degrees, or 3x is going to be 180 degrees minus the arc sine of minus a quarter plus k times 360 degrees, or x for the 10 one is just the arc 10 once plus k times 180 degrees. Okay, so that's the stuff that we have. I would like to jump for the jugular now. Okay, not yet. So we know that basically 3x is going to be the arc sine of minus shift sine minus 1 over 4. So it gives us a minus 14,4775 degrees plus k times 360 degrees, or 3x is going to be so this would have come out negative, but then we add, and it makes sense that 10 would be positive there, 180 plus, right? Or sine would be negative because it's negative in the third quadrant and fourth quadrant, so that's a fourth quadrant. This gives us the dirt. Okay, so here what we need to do is just add 180. Excuse me guys, I don't know what's happening. So this one is going to be 194,4775 degrees plus k 360 degrees, or x is going to be, let's see, shift 10 5. This one is just 78,69 degrees plus k times 180. Now we jump for the jugular, therefore maybe let's jump a space so that it's clean, not too cluttered. X is, we go back, so say minus 14,4775 divided by 3. So this gives us minus 4,83 degrees to 2 decimal places plus k. Now 360 divided by 3 is 120 degrees. Or x is, so we say 194,4775 divided by 3. This gives us a 64,83 degrees plus k times 120 degrees, or x is 78,69 degrees plus k 180 degrees. So these are the general solutions. Okay guys, this one is easy, dealing with trig functions. It's a grade 11 question, honestly, so not a big deal, so I don't expect any issues here. Right, guys. So yeah, this is the fourth quadrant. It's very easy. So minus 4 times 3 is minus 12. So this is a fourth quadrant. So sine of 3x is definitely negative there. And then this one is going to be 64 by 3. So 64 by 3 goes to 194. This is in the fourth quadrant stem. No? It's in the third quadrant. So again, sine is negative there. So this still speaks sense even here, because x is triple in the sine function. So this is still good. 10 is positive in the first quadrant for sure, as well as second quadrant. When say 180 plus that, it goes, third quadrant, it goes to the third quadrant. So these solutions are proper. So 1 mark for each, baba. There's the 3 marks there. And then for this solution and that solution, 5. Hey. Maybe we can give this one. At the end of the day, when everything is right, guys, you get full marks. There's no stories. So this is a nice 29 marks. Plus or minus, in fact, minus 7 marks, because from what I can see, guys, this first 4 marks, it looks like you were not expected to get it right. But this one, you could not. Again, it was made tricky. No problems. Let's get to our functions. So question 6. Question 6 says, in the diagram below, the graph of f is equal to minus 2 cos x. So what do we know there? Coefficient of the angle is negative, so that means our maximum is going to go to 2, minimum to minus 2, but the negative says it's a cosine function reflected about the x-axis. This was supposed to start there, now it's down there. This one was supposed to be down there, now it's up there. Good. So it's a vertically reflected cosine function, which is also augmented by 2 units. Great. And we're given the domain. So this is minus 120. So this is minus 90, 60, 30. So 30 from here is going to be exactly minus 120. So we are not shown that so that we can struggle. Minus 120 degrees over there. And we know that this is 180 plus 30 gives us 210. Is it 210? Yes, 210 plus 30, it gives us 240. Okay. Right. Now, we are told to draw the graph on the same axis. Of course, we don't have the answer book now, but remember, when the instruction is clear, it goes there. But I'm going to do it here now. Sketch the graph of G, which is sine x. Now, what we see there is that G is a graph of sine, standard sine graph shifted to the left by 30 degrees. Sorry, 60 degrees. So this is a graph of sine shifted to the left by essentially 60 degrees. Now, we are to draw this graph. Oh God, what am I saying? So we are to draw this graph and indicate the x-intercepts with the axis, as well as coordinates of the turning point and the end points. So end points, coordinates of the turning points, and intercepts. So 3 things need to be clearly shown. All right. Now, guys, I know things. You see, once you know things, you don't struggle, because we know that this is the standard sine. So 0 will shift 60 degrees. So it's going to be here. Right? Right. And then 90 is going to shift 60 degrees. It's going to go to 30. Right? 180 was an intercept. It shifts 60 degrees. It goes to 120. Now, we know that 270 would have given us a minimum. So 270 goes to... Is a laganin. Makesibone 270 minus 60. I but yeah, 210 indeed. And then of course the last one, we just plug it as it is, otherwise we will run into problems. So we just go straight to the function and plug 240. So we've got sine, we just say nicely it's going to be 240 plus 60, because this one going to be what would have been ahead. It gives us root 3 over 2. So this one is just after 1. Okay, that's the end point. So obviously we know that this is just 30 degrees ahead. So we know that this one 30 degrees before is going to be the same. The sine function is symmetrical. So it's very nice in that. And then of course here we would hit halfway. And then here we are exactly halfway. And we know there that we should be closer to 1 but not quite. And then it repeats. Closer to 1 but not quite. And then we should be halfway there. From there we should be halfway. The symmetrical nature of this graph, and then this one is saying we're gonna just get close to 1 but not quite get there. So this one ends before. Can you see? I did not even waste time calculating anything. Okay, maybe I did. But even the 120, I mean, if you look at it, you can just plug it directly and say sine of minus 120 plus 60. It's exactly the point. So the symmetrical nature will just make it easy. So there's our graph, guys. So this is the graph of G. Now we're supposed to show the end point. So the end point is over there, you know, and the end point is also over there, you know, and we're supposed to show the coordinates of the turning point. We know that this one goes over there. I hate to do otherwise, so we want to make it clear. This one, maybe let's make it down here. So this one is like that. So we need to write down those values. We know this is 210 degrees. We need to write that x-intercept 90 plus 30 is 120 degrees. This one is 30 degrees. That one is minus 60 degrees. Yeah, it's done. So we've shown the intercepts clearly. We've shown the turning points clearly. And of course, perhaps this turning point, we need to show it nicely as well. That is on this line. Because I'm lazy. Once you write the coordinates on the graph, it becomes ugly, man. It becomes ugly. So that's essentially the story. Okay, guys. So 6.1, we get our 4 marks there. Okay, so 6.2, graph interpretation. So write down. So we've got 6.2.1, the period of G. So G, we look at the coefficient of the angle. So the coefficient of the angle X is 1, so 360. It's not going to change. So this is 360 degrees. Easy one, mark. So we've got 6.2.2. We need the range of F shifted down by 3 units. So the range here is going to be equal to a set of Y values such that Y is less than or equal to but greater than. Now we go to the graph of F. We see the graph of F has a maximum at 2. We then take it down 3 units. So this goes to -1. And then the minimum is -2. We take it down by 3 units. Sorry, I made a mistake. The minimum is minus 2. We take it down further, it becomes minus 5. Then we go to the maximum 2, we take it down 3 units, it goes to minus 1. Done. Okay, I don't even need to underline this. So we get a mark for those. Again, guys, this is an easy question, so get it right. So we've got 6.2.2 says the number of solutions of f of x is equal to g of x in the given interval. So we know that it's here between minus 60 and minus 90, and here between 90 and 120. There's only 2 solutions, so we just write 2 solutions. Easy one, Mark. Okay, guys, so this is cool. So we go to 6.3. Oops. 6.3 says, for which value or values of k is g of x minus k equals 1 will have no real roots. Okay. All right. There are many things to think here. Okay, g of x is the graph of the sine function, and we are shifting it vertically. And that should be equal to 1. I think this one is incomplete. So we need to write it down nicely. So g of x is equal to, minus k equal to 1. Now we want to sort it out, so we can say g of x minus 1 minus k equal to 0. Only then we can solve, right? Standard form. The graph or the equation must be equal to 0. Then we can start thinking. Now, once it is like this, guys, we can clearly see that technically this implies that we are saying we have sine of x plus 60 degrees minus 1 minus 0 equal to k. Now we know, guys, that this is a vertically shifted sine function by 1 unit, first of all. So we can think of it as a shift, a vertical shift, what is happening. So if we do this, so I'm going to try to strategically crop this one alone, because I want to move it nicely. So it's going to give us some troubles, because it's not that easy to do it. Okay, so there's the graph. It's nicely selected. So now we're moving it 1 unit down vertically. So from 1 to 0. There it is. And then we are saying we are supposed to move this one k units either up or down. So let's say we're moving it down. So k units down. Can you see? Just below 0. If k is less than 0, we can actually see that, minus k is less than 0. We see that this graph will not touch the x-axis. So therefore, that would be indeed non-real roots, because non-real roots means it doesn't touch the x-axis. So we can see that, okay, technically here, we are saying here, technically minus k must be less than 0 as a whole. And then when we solve for k, we know that k must be greater than 0. Makes sense? That's one solution. Because when k is greater than 0, meaning it's a positive number, it's going to be affected by the negative, and it will shift the graph so that it looks like the way it does here. Okay, right. Now let's go back. Or first we write the first solution. We can say therefore here, we can say here therefore k can be greater than 0, or we can see we need to explore a bit here. All right, we take it back. Let's just take it back to its original position and then start working again. So I just want to do this, guys, nicely so that you can see what is going on. I need you guys to learn the trade. I actually like these digital things. At first I did not really like them. But now I can see. Again, guys, we're saying this graph is first shifted down 1 unit, and this is what happens. But now we're saying, is it possible that we can shift it up instead? So can you see we're sitting at minimum of -2. So now if we shift it 2 units up, it's going to touch. And then if we shift it by more than 2 units up, it's going to look like that. So this means we want to say, okay, our k here, sorry, minus k, can also be a value greater than, remember minus k as a whole, it must be greater than 2 because we're moving it up. But as we solve for k, we realize that k must be less than -2. And it makes sense because in our equation, we see that minus k is negative. So if k is less than -2, let's say -3, -2 is going to be +3. And if we're shifting this 3 units up, it's going to be definitely not touching the x-axis. So that's another solution right there. So we can say here, or k must be less than 2. This is when we are thinking of a shift. Right. Again, the question just said for which values. It means we are determining it. We don't necessarily have to calculate it. Right, so that's the story, guys, that comes. So that's the first way. I'm going to show you other possibilities because remember, guys, there are some easy ones, there are some hard ones. Okay, we are back to the original position. Now, how about we manipulate this equation so that it looks like this. So we have g of x, we shift everything, it's going to be 1 plus k. Now this is the same as saying we've got the function y is equal to g of x and the function y is equal to 1 plus k. Mind you, this is a constant, so this is a horizontal line because k is not necessarily a variable. So this is a horizontal line. So we can think about this as if we are drawing horizontal lines. So if we say we draw a horizontal line, say somewhere here, before we touch, this is going to be the line y is equal to k plus 1, okay? And we strategically draw it right at the turning point of our graph. This is when we've got again the line y is equal to -1, meaning this thing is the value of k plus 1, basically. And then let's just keep doing it. Then we say, okay, when we do it here, this graph cuts through our graph. This line. And then we hit that turning point. Of course, choose turning point in between and away, okay? It's always safer that way. Of course, I'm just overdoing it so that you can appreciate the art, and then we can make it bigger than that. So all of these lines are all the lines y is equal to k plus 1, y is equal to k plus 1, depending on the value of k. So the horizontal lines, I find it easy sometimes to deal with because, can you see, this graph intersects, so it can't be. This one intersects the graph of sine. No, but this one does, and this one does. So what does this mean? It means we are saying k plus 1 must be less than this value, the -1. So this is less than -1. Because when that is the case, that line will not touch the sine function. If we solve for k here, this is going to be k is less than -2. One of the solutions there. Or we can say k plus 1 must be greater than the value at that turning point. And when we solve for k there, we can see that k is going to be greater than 0. One of the solutions. So this one is much easier and much nicer to handle. Okay, so I always find this technique much better. All right, so this is essentially an option of providing this answer. So of course, guys, we're learning, so don't worry too much about time. So we can either say this was g of x minus k equals 1. Therefore, we're looking at g of x equals 1 plus k. Therefore, by inspection, we know that k plus 1 must be less than minus 1. Okay, just show that we are doing the solutions now. Excuse me. So we're gonna say therefore k, what is this, 1 plus k must be greater than 1. So the solution is that k must be less than minus 2 or k must be greater than 0. Nice and dandy. Okay, it's easy, Baba. Once you know what is cooking. Okay, guys, so that is the story of using shifts because it helps us greatly. That was not part of what we are trying to solve, but we're using it as a means to an end. But our graph must be presented nice and clean. Now, guys, let me show you the algebraic technique because you need to not fail these answers because there's no specification on how to solve it. Excuse me, guys. So now I would say writing this thing in standard form, either that way or that way is fine. And then getting these because we know what we did. Is it 3 marks thing? Or writing it this way. And then, of course, there's solutions, 3 marks, nice and easy. Or we look at this last technique. Of course, I'm just trying to push you guys to not being afraid here. So we know that g of x minus k equals 1. We can easily say this means g of x, in fact, let's just jump for the jugular this time around. We've got sine x plus 60 degrees is equal to 1 plus k. Now remember, the sign is only valid when this value, let's say 1 plus k, is less than or equal to 1 but greater than or equal to minus 1. That's the definition of sign. Maximum is minus 1, minimum is 1, and anything in between. So this is valid. Now when this is invalid, we can say for non-real roots, it is such that 1 plus k must be less than minus 1, or 1 plus k must be greater than 1, isn't it? Because outside this range, then the sine function is not going to be defined. Then we solve for k. We can say therefore k must be less than minus 2, or k must be greater than 0. Again, it's done. But it comes from this business right here, that this is only valid under these circumstances. This is part of rough work, of course. We don't want to see it. All we need is the final finish in style. Okay. So this is on the nature of roots using trig functions. So don't cry and say, but how am I going to do it? I've shown you multiple times. Okay, guys. Yeah. We can safely say you are a higher grade question. Now let's look at the last one. The last one. Of course, if this approach was chosen, guys, writing it like this and those solutions, that's how we score those 3 marks. Okay. Now 6.4 says the graph of h is obtained by reflecting g in the line x is equal to minus 30 degrees. So now we need to find that line. Where is it? So this is minus 30 over here. Okay, so of course it's not part of this business, so we're just going to try and look at it. Okay, so we are reflecting our graph over a vertical line, basically. This is a vertical line. So when we reflect about a vertical line, we are doing, remember, if this is not any of the axes, we are doing two transformations. Right? One is a horizontal reflection about the horizontal reflection, and of course students may say it's a reflection about the y-axis, right? The second reflection, transformation, we're going to translate. It's a translation to either left or right. This time this is to the left of the y-axis, so this is going to be translation to the left by 30 degrees. So basically this kind of a thing, whenever we reflect any function about a vertical line, not necessarily being the x-axis or the y-axis, sorry, not being the y-axis in this case, then it means we're going to do two reflections. One, a reflection about the y-axis, and then a translation. We're pulling it. This is on the basis that if I was to show you guys, if I can say how far, let's just pick a point now. We want to pick a point that is easy to see and maybe visible, but let's just pick this one and say from this line to this point is how many units? So we can clearly see this is essentially 210 units or degrees, whatever. Now when we reflect our graph about okay, no, this is not right what I just did. I want to show you something. So we want to say from that line of reflection, how far is the turning point? For example, this turning point, we can clearly see that this is essentially 210 plus 30, isn't it? Minus 30 is going to be plus 30. It becomes 240 degrees in length, right? So when we reflect this graph about that line, it means we need to find this distance on the other end. That point should flip so that it is, you see this one, this point right here should be exactly that distance on the other side of this line. So this means this point should be here. So of course this must be, if we're looking at from that line, we want to go to 40. Now we can say from minus 30, we take minus 30 to 40 to the left. So we can say minus 30 minus 240. It gives us minus 270. Okay, so that end point is at minus 270. That's what should happen. Okay, but when we only do the reflection about the y-axis, which is the horizontal reflection, the one thing that's going to happen is that this thing is going to be on the other side. You see, it's just going to be like this. Can you see it falls short? It falls short. So a reflection about the y-axis only falls short. So that means we need to drag it some 30 degrees to the left so that this reflection is complete. As you can see, this involves two things: horizontal reflection and then a translation horizontally as well. Right, I hope you guys can appreciate that there. So this is what this means. I hope you understood everything. Of course, guys, practice makes perfect, and again, practice that is focused, and it's not chasing time, because you're not going to learn anything when rushing things. So basically this is what we see here. So essentially we can just answer now and say h of x. So this is a higher grade. Sorry guys, so h of x is basically the graph of g horizontally reflected. So we know that this is going to be minus g of x, right? And essentially, what was the original, like this 60 degrees? But we are translating it 30 degrees to the left. Now, to the left in the equation, we add 30 degrees inside. So this is the mathematical notation for that kind of translation. Now we go on and say h of x is going to be minus g. Sorry, we now substitute. Actually, I did not write the correct thing here. This is minus g of x plus 30 degrees. That's what this is, right? So this one is now minus sine. Now instead of x, we're going to say x plus 60 degrees, the original, and then the 30 that we are now doing. So we go on and say h of x is equal to minus sine 60 plus 30 gives us 90 degrees plus x. So therefore our h of x is 90 is going to be cos, but because of a negative it's going to be minus cos x. And of course we're told to show this in the simplest form, so that's the one. So again, that's a true higher grade question. Again guys, with functions there's always easy questions, range, period, whatever. But we will be having a question on nature of roots somewhat. And we do have questions on transformations. It's always there, and those constitute higher grade questions. Sometimes we may be looking for points of intersections, maybe interpreting some gradients, be it increasing, decreasing. There's a lot. But now because of time, guys, we're not going to go through it. So this transformation is good, 1 mark. And essentially, how many marks? 2. Buffet. Okay, that's it. That's the one. That's the one. Perhaps this one is even better here rather than there. Okay. 2 marks. Again, to protect you guys if you don't get it right. But this was a very easy 13 marks to get, perhaps with the exception of the last 2 questions for an average student. But a student who studies maths and does everything. But guys, if I can make you laugh, this question, if any one of you watched my videos before the trials, you see the video I termed mathematics paper 2 practice for trials and finals. Actually, I highlighted that students should practice this question. I told you guys there's an element of being a magician in a way in me. I don't know why, but it always happens. I sometimes tend to guess right most of the time, but not always. But again, this is to say, guys, if you are religiously doing the things I suggest to you and you don't ignore the work that I do for you, you will definitely have an advantage, because to draw this function, I'm sure it should have been easy. Then the first few interpretations that give you an advantage and leaves you a chance to just deal with 6.3 and 6.4. Can you see? You would have saved a lot of time if you practiced as I suggested. But again, you guys are very special in that you ignore things of high quality, things that make you work. You don't want to work, you guys. You just want to watch. That's the thing. Even when you watch, you want to put time to that, and that's not right. You want to rush, and then you think you're learning. Save time when you don't know anything. You will lose everything, including that time. But when you know things, you can save time and win everything because you are using your time well. So there's a difference, guys. So motivational talk that is not focused is dangerous. Anyway, let's move. 7.1 says, in the diagram, CD is a vertical pillar. Right, so this is indicated 90 degrees, right? A, B, and C are points in the same horizontal plane we normally shade. AD and BD are straight cables. Okay, fine, we can see that. CD is 15, BD 20 meters, ADC 28, okay, and ADB is 52, right, that is the one. Now we need to find AB, so there is AB. Okay, so guys, if you watched the video again, where I showed the strategy, you solve all the angles. Then you start with the structure that has the most information, at least 2 angles and a side. Because you can clearly see here, we don't know much, we only have 1 side and 1 angle in this triangle. Alright, so as you can see, this triangle, which can help us answer directly, we have no other angles, only one side, so that's not enough. So we need to find the one that has more, right? So obviously, if we look at this yellow shaded triangle, we'll see that we've got a side on this triangle. We've got an angle and another angle. So this is perfect for business. So we start from that triangle, we work towards the common side, which is the hypotenuse side of that triangle. Then that hypotenuse side will then help us, because once we have another side, we've got an included angle, we can spell out the cosine rule. And our things are going to go. So if you don't listen to advice, little shwa, lebeselia, shiabalala, little shwa, alisa mamel. Now, first of all, guys, we can see that we've got the angle, right? We've got the angle, we've got the adjacent side. We're looking for the hypotenuse. That's cos theta. So we can easily say, well, cos of, specify the angle, 28 degrees is equal to the adjacent side, which is 15, divided by the hypotenuse side, which is AD. Right. So this one we don't need to explain. It's obvious. It's a right angled triangle. So we can say this implies that AD is going to be 15 divided by cos of 28 degrees. Therefore, AD is, so we've got 15 divided by cos of 28. It gives us a 16, well, we can say 988.6 meters for now, to protect, because it's an intermediate answer. And we were not asked, so we need to be careful. We can't present it as 2 decimals already. We can say then, in triangle, because now we have moved AD, ABD, but the naming doesn't really matter, guys. We know that basically AB squared is going to be AD squared plus BD squared minus 2AD BD. Cos of ADB. That's the cosine rule there. So easy, guys. So this implies that AB is going to be the square root of all that shenanigan. So AD, we know it now. This is 16,9886 squared plus that one is 20 squared minus 2 into 16,9886 times 20 times the cos of 52 degrees. Okay. Therefore, AB is... Alright, let's get it done, guys. So we've got the square root of 16,9886 squared plus 20 squared minus 2 into 16,9886 into 20. into cos of 52. Okay, gotta be very careful here. There's too many brackets, but they need to balance. So we're getting a value of 16,44 meters. Okay, the final answer, 2 decimal places, and the correct unit must be given. All right, guys, so this is easy. Technically defining the cos of 28 and then solving. That's very important. Setting up the cosine rule. Yeah. Substitutions. Yeah. Then the final answer. Yeah. Easy, 5 marks. Nice and easy. So let's get to this one. 7.2. 7.2 says J is a point on HM of triangle GHL, right, the big one, such that HJ is equal to JL, which is equal to K units indicated. HA is the italicized small letter A. Angle HGJ, it's an italicized small letter B. Okay, there it is. And then of course J is divided into 1 and 2 angles on a straight line. Cool. So now we need to prove that this area of triangle GJL. Okay, so this triangle over here, the area of this triangle is given by K squared. KK is here as well, sine of italicized A. Okay, that angle, and then sine of A plus B. Which angle is that? It's actually this angle. It's the exterior angle of that triangle, this one. Okay. So that angle is going to be A plus B, all right? Okay. And then it's divided by 2 sine B. So again, this already is saying same strategy. We always start with the structure where we have at least 2 angles on the side, and this one ticks all the boxes because this one only has 1 angle on the side, so it's not enough. And of course, what we're going to do, we're going to work towards the common side. Same strategy. Right, so we will say, nice and easy, we will say essentially GJ, because that's what we want, divided by sine of the angle opposite it is the small letter A, is going to be equal to HJ, the side that we know, divided by the sine of the angle opposite that, that's small letter B. So we know that this is the sine rule in triangle GHJ. Okay, nice and easy. So what are we trying to do? Just cross multiply that, so we can say GJ gonna be HJ is just K times sine A, all divided by sine of B. Okay, that's cool. Now that we have it, we go on into the other triangle. In triangle GJL, what do we have? What we've got there, we need to define that angle. We know that angle J2 is basically angle alpha plus beta. Of course, not beta, but A plus B. So again, what do we know? This is the exterior angle of triangle GHJ. But now this helps us to work in that triangle. We can say then, we understand that area of triangle GJL is going to be half JL times GJ times the sine of the included angle, which is sine of J2. Right, we then substitute. This is half of JL is just K. Since this is fractions, we can say over 1. GJ is what we found above. So this is K sine of A over sine of B, right? Times basically sine of angle A plus B over 1. We now have our final answer. So all the numerators multiply, we get K squared times sine A times sine of A plus B, all divided by the denominators multiply, 2 sine B. Okay, that's it. It's clear writing. Okay guys, so again, strategy was nicely explained before, so you have no excuses. So this is 2 marks, right? Then this is the 3rd mark. Very important stuff. Setting up the area rule, technically, you know, substituting. That's 4. Okay, maybe setting up the area rule in terms of the triangle. The answer kinds of tricks down into what we have there. So easy 5 marks there, guys. And again, a very nice and tasty 10 marks, which I believe students got in their majority. Those, of course, will pay attention. Now let's get to the big boy, the big bad boy of paper 2. Because girls are never big and they're never bad. Okay, so yeah, this one is the big bad boy. All right. So we're almost there, guys. So hang on, we will just do it quickly. Now 8.1 says, in the figure below, O is the center of the circle. P, Q, R, S are points on the circumference. So meaning these are concyclic points. Okay, we see the contour and we see the points at the circumference. There they are. And there they are. Okay, right. So now what else do we do? Okay, such that QR is equal to RS already indicated, and O2 is 2x, and then we've got the reflex O1. All right. Right. So what can we do with this? Well, usually here there's not a lot, guys, but what we need to appreciate is that these are ready, right? So what happens? RSOQ is a kite. That question can be asked, so you need to know. Right, and then we've got an isosceles triangle. So this means this angle here must be equal to that angle. Okay. Right, the same goes for these ones. They will be equal, angles opposite, equal sides. Okay. And that's about what we can do so far. Oh, one other thing, we can see there that angles in the same segment are equal. So this one is also equal to that. Angles in the same segment subtended by arc RQ or chord RQ. Now when the diagram gets busy, guys, we stop, okay? We stop and then we start answering. So we have 8.1 with 8.1.1. It says express the following in terms of x, giving reasons for all statements. Not just some statements. Now, we need QRS. Okay. So QRS is here. Okay. So the strategy for that, we can use angle at center equals 2 times angle at circumference. See, this major arc subtends the reflex angle and it subtends that. So that's cool. We can use that. But now we'll be forced to find O1. We know that angle O1 plus angle O2 is going to give us 360 degrees. That's a revolution. Sometimes we say angles around a point. Again, guys, be systematic in approach. Don't rush. Solve things nicely. You will be surprised how well this thing is going to help you when dealing with difficult questions. Because you see links start to show up easily when a systematic approach is taken. This shortcut business leads you to lazy thinking, and you just easily get overwhelmed by very simple questions. Now that's the first thing. But we know that essentially 2 times angle QRS is going to be equal to angle O1. We know that angle at center is equal to 2 times angle at circumference. All right, easy. See, nice and easy, guys. 2 times QRS is going to be 360 minus 2x. Therefore, QRS is 360 by 2, it's 180 degrees minus x. Es klaar, Daiden. Yeah, we're getting 3 marks. This one is the essence of it all. Statement and reason, powerful, final answer. But these other ones must come up. 8.1.2 says we need Q1. Okay, so this means, all right, so we actually are landing into that triangle. So this is an isosceles triangle, makes our lives a lot easier. So we can say safely in triangle QRS. Say these things, guys, have a structure and a method, right? We know essentially that angle S1 is equal to angle Q1. Now these are the angles opposite equal sides given RQ equals RS. Okay, please be very brief and clear and to the point. We can say then, we also know that basically angle Q1 plus angle S1 plus angle QRS 180 degrees. This is the sum of 3 angles of a triangle. We are talking about this one. Now we know that Q1 and S1 are the same, so this is the same as 2 times angle Q1, which is what we want, plus this QRS, we got 180 degrees minus x equals 180 degrees. This implies that 2 times angle Q1 is going to be 180 goes away, it's x. Therefore, angle Q1 is going to be a half of x. Okay, cool. This is easy. Again, that statement is key. And maybe the substitutions here, the sum of 3 angles is not a big deal, but even the substitutions, perhaps that is more powerful. And the final answer. So we are doing fine, guys. This is a warm-up, all right? It's a warm-up question. 1.8.1.3. First, guys, I'm going to publish this memo in the description below, so you will be able to download it, right? And I will also have a link to the question paper so that you can have it, those who did not sit for this paper. But those who sat for this paper, perhaps you may want just a memo, since you will understand it, how it was written and what it means. You've got a video to supplement it, right? Right, so we want angle P. Angle P, kimanzi amancane, kimanzi amanqini qemos. Hey, ruka jwale. That is the one. So we know that angle P is equal to angle S2. These are angles in the same segment, right? Subtended by chord RQ. So we know that angle P, sorry, there must be a cap there. Angle P is equal to, since S2 is equal to Q1, it's going to be also half of X. Done and dusted. So this one, statement and reason and the answer. Okay guys, those were the easiest 8 marks a student can look for. Of course, there is a lot of questions that one can ask in there, but now let's leave it for later. Right, so we are done with the warm-up, folks. Easy marks, easy marks, easy marks. 8.2. Tenda ballistic in Pambene. 8.2 says in the diagram, triangle ACE, the big one. So that is the triangle. Has point D on AC and F on H. Sorry, and F and H on AC, okay? Such that DF is parallel to EA. DF is parallel to EA. DF is produced to G, meaning it's the straight line. A, G, B, G, H, and BC is drawn, okay? With BC parallel to GH. And then we're told that HF is equal to FA. Okay, that is indicated. DE to CE. Okay, DE. Now the ratios, guys. That is 2:5. So this means if we say this is 2A, this is 5A. And if that's the case, it means CD must be 3A. Okay, we always choose a multiple there because this is not an answer. As in the final answer, it can be the simplest ratio from big numbers actually. So never make the mistake of substituting them directly like that. All right. So what else? We're told BG is 12 units. So there's BG. This one we're told is 12 units. So we're going to write it as 12 because that's the unit it is. Okay. Now we need the length of AG. Okay, where is AG? This is AG. Okay. So no problem, guys. So this is clear that our technique needs to be such that okay, so basically, all right, so this means for us to find that we need to end up there. So this means we're going to do the same strategy. Start where we have more, we work towards. So what is going to help us here is to find this ratio over that ratio, right? I think that's what's going to help us. Manyana, boy, batla ring piano. Nearman. So technically, no, that's not a good strategy. But perhaps that ratio over that ratio. See? Yes, because seeing that these two ziyalingana kanje, we are home free because whatever we have there, it's going to be the same as that, okay? So this can help us to find AH, and then we add everything up to get AC, and that can help us to deal with our issue. All right, so of course, guys, using our ratios, if this is 2, this is going to be 2y. We choose a different multiple. So this big one is going to be 3y. Of course, proportionality theorem, y, because this side is parallel to that. And since we know that that is 2y, that's going to be 2y as well. So that's about it. And if that's the case, this means this one is just y, if we need it at all. Okay. So it looks like we're taking those 6 marks. Nice and easy. So first of all, we're just going to start city AF over FC must be equal to DE over CE, whatever that is. Right, what is that? Prop theorem. We need to specify that DF is parallel to AE. Without the parallelity in that triangle, that doesn't hold true. Okay, so this implies that AF over FC is going to be basically 2A over 5A. Okay, maybe we could have just left it as it was given, but it's fine, guys. Sometimes some things don't matter. This is 2 over 5. Okay, that's what we want, because these ones will divide to 1. 1 is a multiplicative identity, so it can disappear from the face. So now we can say then, we know now, actually we need to specify in which triangle this is. In triangle ACE. Okay? Yeah. That is not DACE, but triangle. Okay. Then, what do we know? We understand, guys, that GA or AG, as it is given, over AB should be equal to AF over AC. Yeah? Yeah, that's what we want. Yeah? Is it AF? No. I'm being careless now here. This one is going to be AH, essentially. AH over basically AC. Yes. So now this is going to be the prop theorem with the side GH parallel to BC in triangle ABC. Yep. Siyabangena. Now AG is our interest. AB, we can see that from this ratio that we have now, it's basically 2 times that, which becomes 4y, plus a ke te pone hore ke rabiana AG and AB. Okay, ndiyibona ke ngoku sendiyayibona. This one is going to be basically AG plus 12. Okay, sendifuna ukubhayisa. Keep focused, Makamba. AH is basically 2 times 2y, so this becomes 4y plus plus 1. Plus 1. Sometimes singayibonakalisa nokuthi siyithole kanjani sithi 2 times 2y, or 2y plus 2y. I mean, we were told what this is. 2 times or just plus, it's easy. AC is basically going to be 2y plus 3y. So that we don't look like we are crazy. AG is basically AG plus 12 equals, this is 4y divided by 5y. Now we don't want these guys, so they must go away straight up. And we cross multiply. So what we end up with is 5AG equals 4AG plus 12 by 4 is 48. Ne. Kiona 48. Specificity sesibonile ke ngoku. In fact, we can conclude, therefore, AG, because 5 minus 4 is 1. Therefore, AG is 48 units. Okay, nice and easy. Okay, that's a slightly challenging question. I mean, the indirect questions are truly higher grade, so yep, of course not too high, could fit both, but whatever. It's an essay type question and we need to pay attention and keep up. So statement and the reason, very important. This ratio was the essence. Statement and reason. This substitution, very important. So 1, 2, 3, 4. And then 5, then the rest boiling up to the answer. So 6 marks in the back. We smile, we move. Easy. 14 marks there, guys. I'm sure you guys got yourselves some marks here. I'm sure you're smiling wherever you're sitting, that I chowed it. Question 9. Question 9 says, in the diagram, the circle with center O, so that's the contour again, we need to know that, passes through F, S, H, and G. Those are concyclic points. And if they are concyclic points, there's already some things we can see. Right, as you can see, there's a bow tie there, so this angle is already equal to that angle. Angles in the same segment subtended by arc FG or GF. This is arc, there's no chord, so please don't find yourself saying chord. Right, so that's what we can say so far. And of course, seeing that this is the center, so we know that these are ready. These are ready. So making this one an isosceles triangle, so we know that that angle G1 and 2 is equal to H. Okay, cool. We are getting somewhere. Okay, the diagram is starting to become busy too soon. Okay, let's see. What is the story? DF and DS are tangents. Now, once we hear that word, we know that tangents from the same point outside the circle to their point of tangency are going to be equal in length. And if that's the case, it suggests that these angles are equal. So these are angles opposite equal sides in a triangle, right? So that's the story. And furthermore, we know that this is a radius, that's a tangent, they meet at 90 degrees. Okay, that's the one. Okay, so we've got it. So SG is parallel to DF, so that is parallel. So that means this angle is equal to F1. So technically these are alternate angles, so this changes everything now. So this means this is also equal to that, alternate angles with parallel lines. Now since these are angles opposite equal sides, that's the case. So technically S1 is equal to S2. That could be a question. Yeah. Yo, sekubhizi kakhulu. Okay, now let's read again. Diameter, so we are hearing statements now. Diameter FOH, so meaning this is a straight line. So if that's the case, that angle is 90 degrees. We can say co-interior angles are supplementary, and therefore if that's the case, this is 90 degrees. Or one could choose a more direct and say alternate angles are equal, so meaning the inside one. I mean, we can do that. I think this one is more safer because co-interior are not necessarily equal but supplementary. But this one is equal because if that is a straight line, it becomes a transversal and these lines are parallel. So that's what happens. So it means we have a right angled triangle here. So this OGR is a right angled triangle. Okay? Right. So what else can we say? Oh, if this one is 90 degrees, guess what it means? This line cuts that line into two equal parts. Why? Line from center perpendicular to chord bisects the chord. Wow, this question is rich with things. Okay, so we're told OG and GH are drawn. Okay, no problem. First one, we need to prove that this triangle DSF, so we need to prove that that triangle is similar to OGH. Okay, so those are the two triangles we need to prove similarity, but you can already see these two angles are equal, so they are definitely similar. But now we need to choose a strategy that makes them equal nicely, you know. You can say that is equal to that, that is equal to that, done. You can say, but this one is equal to that, while that one is equal to that, therefore those two are also equal. Once we prove two sets, we are done. Easy, easy, easy. 9.1, we're going to say in triangle DSF and triangle OGH. Okay, this one, we know that on DSF it's F1. F1 is equal to S2, right? Alternate angles with DF parallel to SG, okay? And we can say also, we know that S2 is equal to angle H. These are angles in the same segment, okay? Right. And so this makes a conclusion that indeed F1 is equal to angle H, okay? Because they link through S2. Nice and easy. Right, we can say here, but what knowest thou? We know, guys, that basically F1 is equal to angle S2. Wait, no, let's not start there. But we know that we know that DF is equal to DS, okay? These are tangents from same point. Okay, so we know that tangents from the same point, from their point of origin to their points of tangency, they should be equal in length, but not beyond their points of tangency, okay? Now, what does this mean? It implies that angle S1 is equal to angle F1. Why? This becomes angles opposite equal sides in a triangle. All right. Of course, which triangle are we talking about? We need to be specific in a way, in triangle DSF. Okay, so this is the story here. So we can say here, technically, likewise, we know that essentially OH is equal to OG. These are ready. which implies that angle OGH, I'm going to call it that, is going to be equal to angle H. These are angles opposite equal sides. Right? Again, we can say in triangle OGH. Okay. So can you see, guys, what is cooking? We know that F1 is equal to H. So basically anything that is equal to H, can you see this H is here, right? And F1 is there. So it means these two angles, S1 and OGH, must also be equal. So we can say therefore angle S1 from the other one should be equal to OGH. Okay. As a result, so we know that each one is equal to H in general through F1. But the reasoning is complex, but I mean, we've set up enough reasons. Now, guys, once we prove two sets, we can conclude that technically triangle DSF is indeed similar to triangle OGH. The reason is angle. The third angle is not necessary because it's already automatical. Is it automatic? It's not automatical, it's automatic. Automatic. He automatic. Hey, the truly gospel, the truth is automatic. Machine shinja. Sometimes it's overexcitement. Nullified. Uyesu wethu. Onguye yedwa. Uyesu yedwa. Namandla. Jesu yedwa. Jesu namandla. Namandla. Hey, maske sithi uyikhalisa kancane. Hey. Dinner now. What the training. What I'm gonna try to finish before this thing takes too long. Eh? I'm gonna try. Sasemaphethelwe. Ithi nguJesu yedwa. Zithi uYesu yedwa onamandla. Hey. kuJesu yedwa, Jesu namandla. Ay masi. High fire, kuJesu yedwa. Just 2 minutes, guys. I-world, siyaku-world, ne? Ayingo-world, one entertainment showtime. See, better. Yeah, well. superb. Kulinyongo sana. Kalagani. Hey, umnyama phakathi light kancane bafowethu. Yeah. That was a short break, wasn't it? Because I don't know how to do it on the TV. Eish, bantwana ndini. Sababetha abantu. Hey. Ethani. Okay, guys. So, yeah. Let's mark. I don't know what I was trying to do there, but I did it anyway. So the statement is powerful, yes, it's grade 9 stuff, but hey, very strong and very important stuff there. The statement and the reason cannot be ignored. Yeah. Afraid so. The statement and the reason cannot be ignored either. And this conclusion here, the final answer here, 1, 2, 3, 4, 5. Where is the 6th mark? Isuka phela. Hayi masinike naleyana. Masinike. Again, guys, you can see it's quite spotty how we get the marks, but yeah. Again, this is to say if you struggle, you don't lose a lot, but if you win, you get your marks irrespective. Yeah. 9.2 says, it is further given that OG is 7.5 units, so this one. And RH, which is this side, is 1.5 units. And then we need the line SG. We want this guy. Alright, so how are we going to deal with it? But we can see our theorem 1 comes in line from center perpendicular to chord. So I think let's deal with all the issues that lead us to saying SR is equal to RG. I think this is where we start, and then we will end up in this triangle. But again, it will uncover that it is a right-angled triangle. We can use Pythagoras to get our business right there. Great. So, a bit of planning there. Now let's start talking. We know that, guys, angle DFO is 90 degrees. This is the tangent perpendicular to radius. First things first, we can say also, we know that angle ORG is going to be equal to DFO, and so 90 degrees. These are alternate angles, given that DF is parallel to SG. Okay, so this takes us there nicely. And if this is the case, guys, we can see that therefore we understand that SR should be equal to RG. We now say line from center perpendicular to chord actually bisects the chord. Can you see? Nice, guys, nice. Beka into zakho, ibeke indaba yakho. Ngafika uqhamazele ba. Izawala ichair, Ufika ubeka indaba yakho ithi samachekile, i-confuse by the way. Systematical. Leza xa seyipopedi vele ikazazi lobe ibicinga entoni okanye ifuna ntoni vele ivume, yabo. Ufuna uyipopanisa, mawufika xhumaxhuma nawe iyeke. Izakubhayizisa i-confidence ifefisana, ungabusaphinde ubuye bese uyadyana. Unethwe imvula linganethi izulu. Alright. So bafowethu sesi-set up ile lento nice and dandy. Now we want to zoom into this triangle. Okay, we can say then. Okay, we can say, in fact, just say in. Maybe let's not even say, we can say but. in triangle ORG, when yabona siyaflow abafowethu masiflowini njengomfula riyalelemela jwale ka metsi nokeng ba re tsertse ba ke metsi a foro ke a lelemela ke mogane ke ankga ke se sepa ke a thella ye wena tla robeya ha o sa ishebe mo tsamayang teng. Let's go. Yay, ke tseng jwale. Okay, ke bona ntho e ke e batlang hantle ntho e ke e batlang monna ke hore OR plus RH wa tshwana le OG. Wa bona ke batla ntho tse ngata ke eng ke di ready ntho tsena hobaneng OR plus RH o lekana le OG radi. Ntho re batlang he ke hore OR ke yena motswalle wa rona re mmatlang re hatamele mona tlo bua le yena ha monate fela wa bona. Empa re tla ka tsela tse itseng bona tse bohlale baneng ha o ka tla fela o tatile tlo ba le ya nthwane jwale ha o no ifumana jwale re batla o ifumana he 7.5 is going to be 6 units aba ne re hloka that OR re tlo kgona hore slip into Pythagoras. We can say then re tseba handle jwale hore RG ke yone re batlang ke RG squared plus OR squared it's tshwana le mang le OG squared. Now ke Pythagoras. As Pythagoras theorem, this one, you see we already established that that triangle is a 90-degree triangle because we said it there that ORG was 90 degrees. You see that things there. Now we just substitute, guys. What is RG? But now we want to express RG in terms of SG because we want SG. Since we said it, there, you see that statement there covers us with the blood of Jesus. You see now that this one is half of SG, but now we square it nicely. OR, we just calculated it is 6 squared. That OG is 7.5 squared. Can you see this thing is doing the things now? It's doing the things now. Yeah. But now let's just do the things a bit more so we know that, guys. We know that the half SG here is going to be equal to the square root of 7.5 squared minus 6 squared. Why one? Re equale hape this one SG o lekana le yona ntwane re shebe mo calculating of intshang jwale di ntshang ka man 7.5 squared minus 6 squared is going the things. Hey, hobaneng jwale ntho ya sekgoyeng ke tsetsa dintho jwale wena ska tlontina wena ungezani jwala ungeza batla mqhala ska toti jwala ska etsa jwala iqhaleni aqhale jwala ska toti man khanto etsa la mona 9/2 yana es nie regresmos oh yeah, this 9/2 is outside the square root. Oh, ngiyayizwa. Hey, nesibatla holla. Ke che ha ke sombone. Ha tshwanang le Jesu. Hai ha ke sombone. Ha tshwanang le Jesu ha ke sombone. Ha tshwanang le Jesu che. SG bafethu. In fact conclude ngokusithi siyakuconclude kwethini. SG must 2 can be equal to what? Now if we multiply, in fact we divide by a half here. This is the same as multiplying by 2. then the 2's go away, so this is just 9 centimeters. Was it centimeters? Units. It's clar. It's no clar diding. Yay! Raibala mathematics bana bantate. Labon in tweno. I raibala. Ibile reibadi sisa jwale. Ai reibadile. La hae ba belaela nyana. Ai. Ba ithetsa fela. Belaela nyana yene ya bona ha mo yama. E dutse fela. Iyemi man. Re tsamaya wa bona. Ai sothele kwana. Iyemi tseleng ya rona. Right, re qetile, I finish, it's clear, it's done, begiwe. Shikophetsa mushumo washo. Hey wena. Nawuqalera. Ngare uyentlela shwese. Ikore. Mishumo nje ngesicanga ukuthi yabona sibalekile sisiyeke. Okay guys, are we agreeing? Let me see 9 divided by 2. This one divided by half as well. Hey. Siya-agreeisha ne? Yeah, 9 units. 9 units. Sihlabe amahlungwana phezulu. You see guys, statements are very important. 90 degrees. Yeah, man. And it's true, this one. And this one even more true. Kage ngoku ingxaki yethu i-1 ke ngoku. Yintoni igama lale nto yonke? Xa zavela ii-marks ziphele pha. 4 qha. Hayi ke ngoku iqalelo siqhela kabi. Anizongixelela uba zonke eza marks phayana asizifumani. Yabona ke nina. Kutsho ukuthi niyasirobha ke ngoku. Yirobhani kaloku leyo. Yirobhani leyo, yirobhani. Kodwa ke guys, xa sizitholile ii-marks sizitholile ne, akukhathaliseki uba sizithole kanjani. Re di kreile, re thabe fela hore re bonahala e ka re tswetse pele. Katleho ke ya rona. Ha re tswelle pele he bana ba ntate. Wa bona he bana beso, nna ke kgathetse jwale ha ke rate ntho ya di-profs wa bona. Hobane ntho ya di-profs yona fela ai ya ntena man. Empa re etse hobaneng hona le di-questions tse kae thunyana. Re qete he nthwena fela. This guy seal. Re tlo isiela man. Nice. So 9, no, sepapa kalongo 10.1 lo. What are we given? We are given circle O with tangent PAQ. Right. Seyigqibile. RTP. This is the method of writing a proof, guys. Don't just fall from the sky. First state what is given, then you state what you are looking for. We are trying to prove that the gap is must to can be equal to restation abantwana A, B, C. We're saying we're not gap there. Utshwana liyane. In fact, alitshwane liyalekana. Jwale re tlo etsa jwang he manyewe? Wa tseba ntho tsa sekgowa manna di monate fela. Gana hantle fela o etsa mosebetsi wa ona o be monate wa bona. E re etse ntho tse monate jwale re tlo drawa kere. Re tlo drawa. Re drawa ntwana, re drawa diameter. Yeah, we construct diameter AOQ, AOR. It's AOR, baba. So we know that we're gonna have a construction statement, guys. We just say draw diameter AOR. And on top of that, we join CR. Wayibona jwale. Sekuyayibona-ke goja ukuthi letho lena ikhapha kanjani. Sisibone-ke ukuthi lokukhapha kwayo lokhu kutophelela kekhi. Ngoba sifuna ukuyibona ukuthi sisakekhe ayiyemi kajena. Sifuna letito sibhayizisa la. Since it's not one lakhana stothi go to lona sibese sithi lakhana go to sibese sithi go 3 lakhana sibese sithi go 4 wabona, because letho nyeti lakhana kodwa sifuna ukuthi confuse lakhana sibone sesiphabene wabona. Asifuna ukuphabana la. Then letho yema kaje wabona. So we can say here join CR as shown. Akethi-ke bathi sinyika le diagram lena lokuthi sesingole lakha kuyo. Asiqeda kungola lakha bese siyayibheka siyibhekisise bese siyasebenza kahle. Akethi ijalo letsaba. Asigene kule proof yakona ke coach. Lesiyathi siput. Aliyathi litho ngiyabona. Okay guys, let's go before I start becoming annoyingly irritating. Use the diagram below to prove that thing. So now the proof, guys, is saying, in essence, we need to showcase that this is 90 degrees, you see. That's the main thing there. So we know that that's the angle in the semicircle. So it's going to be 90 degrees. The second thing, we need to say that even this one is 90 degrees. Why? Tangent perpendicular to radius, you see. Sorry. Yeah, that's the one, guys. Then we know that technically that angle is equal to that one. Why? Angles in the same segment subtended by chord CA or arc CA. Then the thing is going to be nicely linked by elimination. So maybe this one is a good one to show as much as I'm lazy. Okay, let's start, guys. We know that angle C1. Let's just not say this C1 business. It's going to irritate me. Angle RCA is equal to 90 degrees. This is now the angle in semicircle. By construction, asundenzele inhliziyo wena man. And this is ezintwana ezithambileyo eziziyoyoyo lezi eziromantic. Qhelakabi man. Ekisni what? We know things, guys. We know things. You see, we know things. What are these things that we know? You say that one is angle in the semicircle, ne? Yeah. Also, we know that angle RAP is also 90 degrees. The tangent perpendicular to radius is one. So what must we can say now? We can say however or our ring angle R plus angle A2, right? Plus angle, what is that one? We said RCA should be 180 degrees. This is sum of 3 angles of a triangle. At this point, so we know that our target is to have angle R here plus angle A2, you see, plus, you see, this is 90 degrees now, equals 180 degrees. So we can make a conclusion that angle R plus angle A2, they are each 90 degrees. You see, this proof is silly, man. Very silly, you see. We can say likewise, although it's not exactly the same, we know for sure that angle A1 plus angle A2 is equal to 90 degrees because that is RAP. Actually, I should have said it there. I distinguish and distinguish apha lento. Fanele nditsho pha phezulu. Yabo. Hodimo kwana. Up there, so we can say apha xa kunje, it means RAP ngubani A1 plus A2 is 90 degrees. So that's what we needed to say, you see, as a conclusion. And then we come with the howevers. Sorry guys for speaking in the vernacular. Sometimes when I become a little tired, you see, this is what happens. I resort to my easy language to speak. Papa food at the same time. You see, so papa is nice, is life, is everything. So bafowethu re batla ho reng jwale, re batla hore. Then you see, then this is an essay type of a proof. We can easily see that, guys, angle R plus angle A2 is going to be the same as angle A1 plus angle A2. Ne? But maybe in the reverse, masiqale ngo-A1 because A1 nguyobizwa kuqala. The cap is angle A1. Masiqale kanje. Then we know that angle A1 plus angle A2 must be equal to angle R plus angle A2. H equals 90 degrees. Now, we can see that A1, A2, uvela macala. So, xa ivela macala uyasuka ne. Ibese isiqalela into ba actually angle A1 ulingana no R ne. We've got a but. Don't go. Siyayazi into ba angle R here ulingana no angle B. These are angles in the same segment. So what does this mean? It means therefore A1 must be equal to angle B. Therefore, we write it as it was shown. Cap S like that, like that, like that, like that. It's done, guys. So it's one of those crazy proofs, but yeah, it's a beautiful proof once you know what to do. So construction statement gives us 1 mark there. How many marks? 5. This one. Bafethu yabona izimarks ziyaphela straight. Nalia. Ngeke soze. I think the essence is down there. 3 marks. And then this equation 4. Then equating the 2. But this one is good, you see. This one is good. Angas, guys. Angas. So, as long as it ends a gilly proof, guys, 5 marks in the bag, okay? No manga BSR 8. Now let's chow 10.2 nicely. 10.2 says, in the diagram, EBF is a tangent. Great. That one. Out to say one. Let's augment you. This one is tangential. Where? The tangent to circle BCD, okay? BCD. So this is a cyclic triangle. So, okay. You know, my cyclic triangles are gonna give us 10 chord theorems and stuff. Yeah, so if this is a tangent to that one, this one is gonna be equal to that one. 10 chord theorem, essentially. And this one is gonna be equal to that one. 10 chord theorem, okay? Guys, interpret statements straight away before you get lost and forget what was given, right? C, D, E, and ABC are straight lines, okay? A, B, C, yabona. This is good because we need to know. Now E and A, with E and A on the smaller circle, like that. So again, can we see the circle, these points touch the circumference, so they create a cyclic quad. You see, we've got a cyclic quad. So what you'll notice, guys, that this becomes a cyclic quad. Okay, if this is a straight line, we know that that angle also is equal to D2, exterior angle of a cyclic quad. Okay. Yes. And of note again, you see that B4 also quickly becomes B1. These are vertically opposite angles. Now this tells us that this triangle is isosceles. Okay, that was quick. Easy stuff. So guys, once you interpret the statements, I mean, you win. I promise you. Yes, you may not win automatically, but come on, guys, it takes you somewhere closer to what you need. Prove that. Wow. You see what I mean? See, we've already done it by just playing with the statements given. So now we know what we're gonna do now. We're gonna go around in circles. We're gonna say that is equal to that, equal to that, equal to that. So we know that angle A is equal to angle D2, exterior angle of cyclic quad. Say A, B, D, E, because all vertices touch the circumference, right? Right. You can say also, we know that this D2 story here is going to actually be 4, right? 10 chord theorem, right? We will say, but what? We know that B4 is equal to B1. Vertically opposite angles. Therefore, angle A is equal to angle B1. Therefore, what is this? EA is going to be equal to EB. These are angles opposite equal sides in triangle ABE. Abe. Ibona yango fana sisimaphambili sikahlelo uAbe. Sisimaphambili sikahlelo bani 2. Uhlelo 2 sisininzi sikahlelo 1. Uhlelo 1 isimaphambili ayiva yango bese sithiwe xa kuthiwa umuntu as an example siye ke ngohlelo 2 asizuthi imintu sithi abantu aba sisininzi sikahlelo 1 yabona abantu bese sithi no abe xa sithi umfundisi asithi abafundisi sithi abefundisi yabona esazi isiXhosa usazi ngasithethi ke ndiyacela because ngiyacaphuka abantu bethetha inyongo bathi bathetha ulwimi lwami andikwatisa wese zingamaXhosa kanye sithetha inyongo ndathi abaXhosa wayifunda phi lonto abaXhosa ikhona into enjalo ayikho guys umXhosa but now the problem is that isininzi ayingohlelo 2 so nana ndifundiswa ngubani umXhosa ne iphaya kuhlelo bani kanene 3 kuhlelo 3 nayo uhlelo 3 isimaphambili sakhe ngu but ke ngoku isininzi sekufu ya ku ame yabona go bese kuba no e khona hayi thenga ndiyabhuda makancinci maki uhlelo 3 kanene ngibani isimaphambili sakhe hey wena thengathi ndipopene njengoku ngathi confuse u3 no5 ne because I think 6 ame I think 5 le ndimpopanisayo uyabo ukhona u-e phayana andazi no ukhona kodwa because asithi iliso andike ngoba besithi by imehlo akodwa kuthiwa libehlo apha iliso not even ilihlo njengoba sithethi isihlubi nje sisitwista sithi esihlubeni lilihlo kodwa kuthiwa liliso ngesixhosa iliso right now xa soyisa kwesininzi awuzothi amaso okanye ameso uthi ngamehlo amehlo yeah u-ili is part of ihlelo 5 sesimaphambili sikahlelo 5 then bese sithi ame right yeah but amaXhosa la xa sithi umXhosa ikhona into mani izimaphambili zikahlelo 5 ndizilibele kodwa ikhona into no-uphaya then bese sithi umXhosa then amaXhosa not abaXhosa siphaa ku-5 and 6 says yeah sanonibhayizisa thethani isiXhosa ngathethi into engayo but andikhohlwa nawa ndiconfuse u5 no6 okanye 3 no4 yo wana sendizi-exposile kodwa ndizazi indaba zam ke nagana gore ke a di tsipa ditaba tsaka gante ga ke di itse ke a senkatšhela okay perfect how many marks 6 perfect 1 2 3 4 5 but since there was no quality asinikiwe statement and reason 2 marks is 6 marks ibethe yoxela sithi hamba ungabuyi hamba ungaphinde wone sikuxolele hamba ungaphinde wone ndikuxolele ndikuchaja kazi hamba ungaphinde wone ndikuxolele kuxolele ungaphinde wone ndikuxolele hamba ungaphinde wone ndikuxolele 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 ungaphinde wone Okay guys, masigqibezele sendiyabhuda. By the way, the song that I sang ingoma yasecaweni ne, it's a gospel. African gospel. I think it means I forgive you, go and never sin again. This is Jesus forgiving someone, you know. Ndikuxolele hamba ungaphinde wone, meaning go, but don't ever sin again. If you do, I'm going to ban you in hell. Now it says 10.2.2, the length of ED. Where is ED? Go shebile, mokoko on shebile. Re khotse hampa seng re gotse re hodile hotwe ha ba betsa nail tove ha ba re mokoko nshebile be bembiza umqoti because he was tall mos. You see mos, the mqoti is tall. What is a mqoti? Is a rooster. Is it a rooster? It's a male chicken though. The male chicken ba re ke mqoti hobaneng ona le mo telele mos wa bona. ED, that one, and then EA, and then EC. EC ngubani ke ngoku yena nguye naye lwana sithi suka phasi yotshona le. Is the second of our circle. All right, it says prove that this in this order forms a geometric sequence. Hey. Let's KZN kwan. Hey lun. Wawana jwale le bua maths. I like it. I dig it, you see. Yeah, I dig that one, man. How can they produce some nice questions like that? Dang. Bruh, you can't be serious. Is that you? Geometric sequence. I told you guys that concepts of paper 1 will surprise you when you get to paper 2, because I know you guys forget. What is the geometric sequence? Now let's say this is our GS or geometric progression. Remember, this one is the first term, ED. EA is the second term, then EC must be the third term, and this is EC, and therefore the geometric sequence is going to continue. But what is typical of a geometric sequence? We know that the second term EA over the first term ED must be equal to the third term EC over EA, because this is the R Corman ratio. So now to prove that EA over ED is equal to EC over EA. Can you see? Nice one KZN. Nice one KZN. I'm gonna buy you a flight. What is it? A jet, a private jet. Please, the one person who created this question, call me. I'm gonna book you a flight to Dubai, see, for a weekend, and everything you want. Okay. You are smart man. Man. You slam man, slam can't this one. It's a slam say it's an uncle, I'm sure. It's a slam say uncle die one. Okay. So basically that's what we need, guys. Now there are two approaches. Technical. In fact, now send for no indulge because this is the last one, guys. Let me teach you something. In this one, if you look at these sides, technically the odd one out here is EA, basically, in the structure that I'm going to show you now. In this structure, do you see that EA is out? But technically, if we say what is A equal to, actually EB, it's part of the tangent EB. Now, there's a 10-second theorem. So if we've got a second, because you saw these are parts of the second and this is part of the tangent. So let me say method 1, okay? We're going to say, well, we know that the theorem says the square root EB squared, the square root of the tangent, is equal to the product of the segments of the second, meaning ED, times EC. Now what do we write here? We're going to say 10 sec theorem. Right. I don't know if you guys are allowed to do this, but I mean, this is still maths. It's not wrong, so why not? But now we're like, hold on, we're getting stuck now. What do we want? We want this guy. So how do we manipulate this thing? Remember the 3-step approach I teach you guys. EB, first of all, is equal to EA, because we've already proven this one. So we can say this is EA squared first, is equal to ED times EC, okay? Of course, we can justify that EA is equal to EB. It's proved. Can even say proved that EA is equal to EB. Now we follow the three-step approach. This is squared. We do reverse operations. So this is EA times EA, exponential rules. You see, this is algebra now. Because you are thinking, this one doesn't apply because you are here. Oh, now there's another logical thing, guys. In maths, we can divide by anything that we want. Now this anything, remember we want to eliminate one EA, so it's going to be EA times. We also want ED off that side, so we can divide by EA times ED. Now if you ask me why, well, because we can. So we have EA times EA over EA times ED. This is going to be equal to whatever we do on the one side, we equalize it by doing it on the other side. So this is EA times ED. Look at the magics. Superb. Strong. Gone. And now what happens? Yes, that one, EA over ED is equal to EC over EA. Therefore, we can say indeed EA, not ED. Therefore, ED is to EA is to EC, and going on forms a geometric sequence, because we know that there is a common ratio. Right, between any two consecutive terms. Nice. Such that EA, let's not prolong it. So you see, logic before two must come in. But again, this is perhaps a higher grade approach. Weak students would not win here. This is more like, taking it from the end and expanding it, you see. Because usually we don't take it from, this is the reversal, more to say. We are reversing things, which you guys normally don't like, but yeah. See, I teach you these things because they are there. They are there. So this statement and reason, I think it's powerful. Now using exponential rules, done. And then the logical step here of getting here, indeed. Then the statement and the reason there, that there is actually a common ratio. Because this ratio is equal to that ratio, so that's a common ratio, R. So how many marks? 2, 4, 5. Maybe the substitution here of EA is a mark. 6. Done. Dusted. Igqityiwe bafundi. But of course, ndiyazi man, nina nifuna method 2, which is the standard method, right? This one is standard. Method 2. This is the standard method or approach. Right, let's quickly do it, guys. We will say in triangle EBD, and now I don't really care how I name it, guys. It's going to be ECB, whatever. But you guys can name them according to whatever, frog face, whatever, but this is needing us to prove similarity here. So guys, this thing, we look at this triangle here, the shaded and yet outlined light blue, whatever that color is, and the big one outside. Normally this is how you guys go about it. We know that angle E2 is common, right? No problem. We can say the other thing, we know that B2 from the one is equal to angle C from the other. 10 chord theorem. Now once I prove 2, guys, I don't waste time. Triangle EBD is similar to triangle ECB. Angle. So this is cool. The third pair is not really that necessary here. Next one, we deal with the proportional sides. Now we know what we're looking for. We want EA to come in first, but now we're going to use EB, the tangent itself. We know that, therefore, we know essentially that EB over. Now, you see, the reason why I don't care about the naming is because I know I'm going to be able to deal with this. So I look at EB. Now, EB, in terms of the big triangle, this time because we can see this one is bigger, so we need to start with the big one. EB is opposite this angle. This angle is equal to that, the side opposite that is ED. Okay, the ones that make up the ratio, guys, are actually the sides opposite the equal angles in the two triangles. So this is why the naming is not such a necessity here. But again, you can do it that way in sweat. It's not a big deal. Next one. I know that I need EC, so I'm going to choose EC, the big one. So EC is the side opposite that angle, B2 plus 3, but that one is going to be equal to D1. On the other one, the side opposite is EB. Okay, we can say proportional sides of similar triangles. Or some people just even write similar triangles only. I see some memos do that as well. Okay, so this is cool. So we've got a but. We know that essentially EA, or maybe let's just say EB, is equal to EA. Therefore, instead of EB, we write EA over ED is going to be equal to EC over EA. And if we prove this one, we can say therefore ED, EA, EC form a geometric sequence. There is a common ratio R between any two consecutive terms of the sequence. Okay guys, nice. Senbalega masongololo because this has been a long lengthy explanation and what. But again guys, I can torture myself for you folks so that you can score the very best of marks. Again, this was very nice. Again, that 10.2 was purely higher grade if you think about it. But more so the 10.2.2 because the question was not posed nicely. Actually, this was the question. This was the question, but it was not posed directly. So you had to figure the question out in the sense of this question. This was beautiful. I agree, guys. So again, if this was the approach, this is a mark, this is a mark, and this is a mark, okay? And this is a mark, right? So 1, 2, 3, 4, and then the replacement 5, and then 6. where we make the conclusion with some valid reason. Okay, so essentially guys, this is how you would have worked your magic towards getting these 17 marks of this question, which wasn't too far-fetched in a way, but yeah, for a total of 150 marks guys, if we did not make any mistakes along the way. But mistakes are a part of learning, so don't sit too much on them, but rather learn from them each time they have occurred. Don't be anti-mistakes, but rather be someone who limits mistakes. Anyway guys, I hope you liked the video and have enjoyed this review, and I hope it helps you guys to really open up your minds, because remember, it's not about answering this specific question that matters, but it's learning on how to answer questions of different sorts, this being an example of such a very diverse question paper in terms of line of questioning, and of course a bit of an artillery there, an artistic way of just asking usual questions, but rather in a manner that forces someone a different path than they would have thought. At the same time, I'm sure you can see my 3-step approach is not just a fluke, guys. It's not even a mere coincidence. It is mathematics. Okay, it's a logical thing in totality. Anyway, folks, you're gonna find this question. You will find this memo. I'm gonna add it in the description box below, as well as this question paper. I'm gonna add it there. And yeah. That's good guys, that's good guys. So I'm hoping you guys are learning something, and I do believe you folks are getting better and better. Okay, there's plenty of videos in the channel guys, and you will see the analysis is very comprehensive, cannot deny that. So use these and learn. But if you want to waste your time and go through unnecessary, mindless and not focused exercises, which you often do, you students, then in the last minute you start wanting to look at serious things, be my guest. But yeah, do it like that. Of course guys, if you can, I just think about it now, if you can, I'm gonna add a 3.6 here. Find the coordinates of J. Okay, so we can say maybe let's say 4 marks. Okay, please, in the description box below, give me an answer. The first person to give me an answer there, I'm gonna give them $200. And I promise the first person to do it and say the right thing. Others who come late, please don't cry. First come, first served, right? Right. That's an interesting one there for you guys. There's plenty of questions I could ask, but let's not do it. Let's not do it. Otherwise, the extra question that I would want here, just for you guys to learn the trade. So let's say 6.5. Like solve for g of x is equal to f of x. Let's just say solve. Or one can easily say for which values of x is this one. Okay, how many marks would that be? Maybe let's be outrageous and say 7 marks. Okay, again, in the description box guys, hit me up with an answer, and the first person to get the mark, so another 200 rand. So there's $200 for this one, there's $200 for that one. Nekasize sinithenga ukuze ndisebenze nina ndiyanazi. Then guys, you can be 400 bucks rich. Maybe let's try and make it a bit nicer. You see mos. Let's make it a bit nicer. Is there any other question I would like to ask? Yeah, there is one. I'm gonna put in a 9.3 here. I can say what is the value of S2. Right, we can make this one 3 marks. Okay, now there's money attached here. If you get it right, guys, the first person to get it right is gonna get 100 bucks. So if you're the first one to answer all these, you're 500 rands rich. I promise you guys, there's my WhatsApp number on the description of this channel. Send me a message, then I will send you what you call them through the money market. Yes, money market stuff. So the Tumelela was buy 500 to Kupa with Standard Bank ATM. If you get all of them, you get 500. If you get one of them, you get the spoils, right? Anyway, guys, goodbye. I'll see you next time.